In this video, I want to show you an example of generics around functions. So we're going to write out one or two examples, and then we'll also see another instance of using type inference around generics as well. So let's get to it. So I'm going to make a new section header down at the bottom of my file, and I'm going to say example of generics with functions. Then down here, I'm going to write out two separate functions, and these are both going to be very simple. I'm going to call one print strings, and the second print numbers. So each of these functions is going to receive either an array of strings or an array of numbers. And both of them are just going to iterate through that array and attempt to console log out each element inside of that array. So for print strings, I'll receive an argument that I'll call simply ARR, and that's going to be an array of strings like so. And this is not going to return anything, so I'll give it a return type of void. So then I can set up a simple for loop inside of here. I'll say for let I equals 0, I less than ARR.length, I plus plus. And then inside of here, we can do a simple console log with ARR at I like so. So now, as you might expect, well, the implementation of print numbers is going to be just about identical. So we could actually just copy paste over that for loop like so. And then the only thing we'd have to update is the arguments on print numbers. So I'd say, well, this thing is going to be called with an array that's going to be an array of numbers, and it's not going to return anything. So once again, we can very easily see that there is 100% code duplication between both these different functions. So a very easy way to fix this up would be to make use of generics. We could create one new function that could receive any type of array, so an array with anything inside of it. So to do so, I could write out a new function down here called print anything. It's again going to have a return type of void, and then to specify that this is a generic function, right after the function name, we could put in those angle brackets and t once again. So then we can say ARR and say this is going to be an array of t types. Then inside of here, we could have the exact same logic we had previously. So for let I equals 0, I less than ARR dot length, I plus plus like so, and a quick console log as well. So now once again, just like with functions, we imagine that this is like an extra argument right here. Whenever we attempt to reference or call print anything, we're going to specify the type of t. And that's going to tell this function that it's going to be eventually called with an array of type, array of whatever t is. Once again, t is not some special identifier. We can call this anything we want to call it, like type of array or something like that. But again, by convention, we usually refer to it simply as t. So then if we wanted to call this function, we could say print anything, put down our angle brackets like so, and specify the type of that array. So we could say simply string. Then we can pass in array of strings. So like A, B, and C. Now, one thing that's really easy to get confused on is whether or not right here in these angle brackets, we should put string or string with square brackets, like so. We would not put in square brackets like so because that would indicate that we're going to pass in an array that is a two-dimensional array of strings. Remember, t is going to be replaced everywhere inside this function definition. So the t right there would be changed to array of strings like so. So we would not put in string with the square brackets right there in the actual generic definition. Now, once again, functions make use of type inference when we are making use of generics as well. So we could technically drop off those angle brackets right there, and everything would still work out as expected. We can now mouse over print anything, and you'll notice that Typescript has already added back on those angle brackets in that function type annotation. And it also understands that the array argument is going to be an array of strings as well. So once again, Typescript has inspected this element right here. It said, oh, okay, this is going to be an array of strings. So Typescript can now figure out by itself what the type of t is going to be. So it's going to go back through the entire function definition and replace t everywhere inside there with string. Now this topic is kind of very similar to using type inference around return values as well. Remember, we spoke about technically when we write out a function, we do not specifically have to add in an annotation for the return type, because Typescript can figure it out for us. However, it's very helpful for you and I to add in that type annotation manually on return types all the time because it helps us check errors. For example, we might accidentally write in a return statement somewhere inside of a function. And if we add in a manual type annotation, as we did right here, TypeScript will help us decide that, hey, that's probably an error, and we probably did not mean to do that. So in a very similar fashion, whenever we make use of generics around classes or functions, I still recommend you add in the type annotation on the generic as well, because it will help you catch errors. So for example, if we said that we wanted to call print anything with something that's going to be an array of strings, well, that's going to help us catch a scenario where we accidentally then pass in an array of numbers. If we pass in an array of numbers, TypeScript is going to say, hey, this was supposed to be a string, but you put in a number right here. So in general, I still, for the most part, recommend you add in a type annotation for generics with classes and functions, even though strictly it can sometimes be ignored. Okay, so let's take another quick pause right here. In the next video, there's one last quick thing I want to show you around generics. So quick pause, and I'll see you in just a minute. In this video, I want to show you one last quick example around generics. So at this point, we've got a function right here called print anything, and print anything is going to call console log with some element inside that array. I want to try building another print anything function, but rather than directly console logging it like so, I want to try to call some like built-in print method on this element right here, like ARR at I. So that's going to imply that our argument of ARR is going to be an array of objects that have some print method on them. That's kind of confusing for me to say out loud, so let's just go through a quick example. So I'm going to put down another section header down here, and I'm going to call it generic constraints, because that's what we are really going to be talking about. So then down here, I'm going to define two very simple classes. One is going to be called class car, and it's going to have a print method. Anytime we call that, we're going to console log out, I am a car. I'm then going to define another class called house. This thing is also going to have a print method. Anytime we call it, I'm going to console log, I am a house. All right, so I now want to define another generic function that will take an array of either cars or houses, loop through the array, and then call the print method on each element. So let's try doing that right now. I'm going to define a new function called print houses or cars. I want this to be a generic function, so I'm going to put on the t right there inside those angle brackets, and then I'm going to say that this first argument is going to be called ARR, and it's going to be an array of type t. And then I'll put on my return type annotation of void as well. So now we can iterate through ARR, and for every element on there, we're going to try to call that print method. All right, so I'm going to say for let I equals 0, I less than ARR.length, I plus plus, and at ARR at I, I'll call the print method, like so. Now, as soon as I do that, we get a nasty little error message here, and it says property print does not exist on type t. So what does this error mean? Well, this is saying TypeScript saying, hey, you're going to say that we're going to dynamically specify type t. So this element right here that we are trying to reference will be of type t. And right now, there is no guarantee that this type right here of t is going to have a print method available. So for example, if we tried to call print houses or cars and pass in an array of numbers like so, this could very easily lead to an error when we actually run this code, because we're basically going to have a number and try to call the print method on it. Numbers in TypeScript and JavaScript as well do not have a built-in print method, so this definitely would lead to an error. So what we need to do here is add on a constraint to type t. A constraint is going to essentially tell TypeScript that we promise that there will be a print method available. So that's going to make sure that whenever we try to call or otherwise reference print houses or cars, we're always going to feed in a type that will have a print method available. So to do so, I'm going to define an interface right above the function definition. And I'm going to call the interface printable. And then on the interface, I'm going to say that there's going to be a print method that returns nothing like so. And now here's the magic. When I specify type t right here, I'm going to say t extends printable, like so. So this is the actual constraint right here. This is us telling TypeScript that whatever type t we put in here, it's going to have all the properties that the interface printable has. So in other words, whatever type t we put in here, it will have a print method that returns nothing at all. As soon as we add that in, you'll notice that the code down here now shows us an error around each of those different numbers. And if we mouse over them, the error says that the type number cannot be assigned to type printable. In other words, a number does not satisfy interface printable. So we are not allowed to pass in numbers to print houses or cars. Again, this is called a generic constraint, and it's going to limit the types that we can pass in for T right here. So we can't pass an array of numbers, again, because they don't satisfy that interface. However, we can call print houses or cars with an array of houses or cars. So for example, I can call this with new house, and so on. And there's no error anymore. There's no error because an instance of a house has a print method, so it satisfies this interface. We can also call print houses or cars with an array of cars, just array of car like so as well. We could even go so far as to put on the actual generic annotation right here. We should do that because I just told you in the last video that we are going to generally add them on. So I can say this is going to be print houses or cars, and the first argument is going to be an array of houses, or the same thing with car as well. All right, so this idea of using a type constraint or a generic constraint is going to be really helpful because anytime that we want to try to call a method or maybe reference a property on some value that's going to be marked by the generic type, we might want to make sure that that property or method or whatever actually exists. And we're going to do that by defining the separate interface and then using that interface when we define the actual generic type itself. All right, now it might seem like this is kind of like a rather esoteric or hard to understand topic, but believe it or not, it actually comes up all the time. And we're going to see an example of it on the very next application we work on. So with that in mind, let's take a quick pause right here. We're going to come back in the next video and start working on our next project. All right, my friends, in this video, we're going to start working on our next project. Now, as I say that, I got a big smile on my face because this next project is going to be a little bit like over the top crazy. All right, this is going to be something pretty darn challenging, but I think you're going to really gain mastery of TypeScript as we go through this. So here's the thing. Just about every course out there, including this one so far, shows how to use TypeScript, but it doesn't really give you real world examples. Like, sure, we learned how to build, I don't know, what were we building, like a report generator and whatnot. All right, maybe that's real world, but not really. You know, at the end of the day, we're all writing web applications. And chances are, if you're here in this course, well, you want to use TypeScript to learn how to do something around web applications. So with that in mind, I figured, why not just show you like really 100% how to tackle and just dominate web applications with TypeScript. So in order to do that, we're going to go super overboard, and here's what we're going to do. We're going to build our own web framework. So this is going to be a client-side web framework, similar to, say, React or Angular or what have you. It's not going to have necessarily the same functionality as those, but it's going to have the same purpose. It's going to fetch some data, it's going to attempt to render some content on the screen, and then handle user events whenever a user like messes with something. So I've got a quick demo of like basically the completed application you and I are going to build. So it looks pretty simple right here, but trust me, there is a lot of code to back this up. What you see is very simple, but you can easily take our framework and without adding anything new to the framework, with just reusing the code we already have, you can make something much more complicated than what you're going to see right here. So inside of the end product of what we're trying to build, we should have some input right here to change the person's name. Notice how this user has a name property. So if I put in something like Alex and hit update name, we should see that update. We should also be able to have a button that says random age and change the user's age like so. And at the end of the day, I also want to be able to persist this data as well to some backend server. So I want to have a save button right here. And if I click on save, we should see a network request appear. And we get some attributes for the user that was just saved to the backend server. All right. Now, I know this looks like a simple application, but like I said, you can take the code that we're going to write here and really build a very full-featured application. I just didn't really build out something too big because honestly, all the time that you and I are going to spend is going to be on the framework itself as opposed to trying to actually build something with it. Okay, so with this in mind and our goal in mind, let's take a quick pause and start going down this kind of long journey right now. So I'll see you in just a minute. In this video, we're going to do a tiny little bit of project setup. So you'll notice I'm still inside of my stats directory here from the last project we worked on. I'm going to go back up one directory back to a workspace folder, and then inside of here, I'm going to make a new folder called web. So that's going to be the name of the project that we're going to work out of. So I'm going to change into that directory. And then inside there, I'm going to start up my code editor. All right, to run this new project, we're going to be making use of Parcel once again. You might remember that we used Parcel earlier on inside this course to get TypeScript running easily inside of our browser. So if you skipped over that video, you're going to need to run a very quick command. You're going to need to run npm install -g parcel-bundler. If you were already installed Bundler, as I showed it earlier on inside the course, you don't need to run that. All right, so once you've got Bundler installed, we can then start to do a little bit of setup over inside of our code editor. So inside of my root project directory, I'm going to make a new file called index.html. And remember what we put inside of here whenever we are working with Parcel. We're going to write out just a little bit of HTML. So an HTML tag. We're going to put down a body. We're going to put a script inside of here. It's going to have an src property, and it's going to point to our root TypeScript file. So I'm going to say, look inside of our root project directory, find the src folder, and then find the index.ts file inside there. Then I'll close off the script tag like so. Okay, so let's now create that src directory and get an index.ts file inside there. So I'll make src, and then inside there, I'll make index.ts. And then once inside there, I'll do a quick console log and just say hi there to make sure that we have everything working. Okay, so I'm now going to save both these files. I'm then going to flip back over to my terminal, and inside my project directory, I'll do parcel index.html like so. And we should see that little pop-up that says installing TypeScript. And then after just a couple seconds, we should see servers running at localhost 1234. If you see an error right now saying something about a port in use, chances are you might have the Parcel server that we were running earlier still running. So make sure you stop that other running server before you try running it here. So now we should be able to open up our browser, go to localhost 1234, open up our console, and see hi there inside the console. Perfect. Okay, so now that we've got something to work out of, let's take a quick pause right here and we'll start working on our project and writing some code in the next video. Now that we've got a starting scaffold for our project, let's start talking about how we're going to build our own framework. Okay, so here's the general idea. Inside of our framework, we're going to have two types of classes. We're going to have something called model classes and view classes. A model class is going to be any kind of class inside of our framework that is meant to handle some data. So we're going to use model classes to represent resources or things inside of our application, such as blog posts or users or images or comments or anything like that. On the other hand, we're going to have something else called view classes, and these are going to be responsible for producing HTML and showing that HTML to the user. It's also going to be responsible for handling events caused by the user, like clicks or typing or hitting the enter key or anything like that. So we're going to try to build up these two different classes. We're going to first focus on building out a model class first. And now to build our first model class, I want to take a look at a mockup that's very similar to the application I just showed you 2 videos ago. Okay, so here we go. So I've got a mockup of the first application we're going to try to build using our framework right here. Now it's really important to understand that we're not just trying to build like this application right here and that's it. We can build something like this using basic HTML and just a couple lines of JavaScript. So my goal is not to build something like this. My goal is to build a framework that I could use to build this or even something way, way more complex. We're going to target this very simple application as kind of like a goal just to give our framework some direction and give us something to work towards. But again, with our framework, we could build something very simple or very complex as well. So I want to take a look at this mockup, and I want to think about the first model class that we're going to build. Remember, a model class is something that is going to represent some data or something inside of our application. When I look at this mockup right here, I see that it's telling me information about a single user. So it looks like a user has some name property and an age property as well. So the first thing that comes to mind when I see this, I feel like we probably need to create a class to represent a user and all of its data, like name and a age as well. So that's the first thing that I think we need to do. Now I want to take a closer look at this mockup right here and try to decide on some of the different attributes or maybe some of the different things that this user class should be responsible for really doing. So I'm going to take a few more notes here on the left-hand side. So when I look at the mockup again, I can tell very clearly that, yeah, this thing is definitely going to have some like attributes. So we probably need some way to retrieve those attributes, like the name and the age, and we probably need some way to update them as well. So I'm going to say that the user class needs to have the ability to store some data, retrieve it, and change it. And when I say store some data, I'm just talking about like keeping a reference around to a string or keeping around a reference to a number. That's it. And then also giving us the ability to change that information over time. The next requirement of this user class that I see very plainly is I see this text input right here where we should be able to like change the name of a user and then click on update name. And I also see that there should be a button here that says set random age. Now those actual buttons are some HTML elements. And so the buttons themselves should probably be handled by these view class things. So we're not going to worry about the actual buttons just yet. But what is much more relevant is the fact that chances are whenever we click on this button and change the age to some random number, or we change the user's name, chances are we would expect the HTML on the screen to be updated as well. So I think that when we change some data related to a user, we need some ability to tell the rest of our application that, hey, this data has changed, and maybe we should do something else, like update some HTML on the screen. So I'm going to say that the user class also needs to have the ability to notify the rest of the app when some data is changed. And then finally, I see kind of one last big requirement here. Remember, we had said that we should be able to click on that save button, or I showed you the kind of completed the application where I clicked on the save button and it made a request to some outside server to persist all the data related to a user. And ideally, we would also have some ability to retrieve that data at some future point in time as well. So I think that the last responsibility of a user would be user needs to be able to persist data to an outside server and then retrieve it at some future point. Okay, so this is three kind of distinct purposes right here. The first note was just saying, yeah, we probably need a user class. These three purposes right here are going to be the first three things that we really concentrate on inside of our framework. So we're going to try to build a user class that gives us the ability to store some data and retrieve it. We're going to make sure that it has the ability to notify the rest of our application when that data gets changed. And then finally, we need to make sure that it also has the ability to persist some data to some outside server and then retrieve it at some future point in time. So I sat down and came up with kind of an API for actually implementing these three different modules, or I kind of came up with a implementation of the user class. So let's take a look at a diagram that's going to help you understand the distinct methods that we're going to create to kind of implement each of these three different pieces of functionality. Before I show you that diagram, however, one quick note on the actual approach that we're going to use for implementation here. So on this first go around, we're going to build up this user class as a kind of like mega class. So in other words, we're going to stuff a ton of methods and a ton of functionality directly into the user class. Now, obviously, at some future point in time, we're going to want to represent pieces of data inside of our application besides just a user. Remember, we are building a framework here, so we need the ability to anticipate other developers' needs. Chances are other developers are going to need to be able to represent a blog post or an image or a comment or something like that, not just users. So even though we're going to target a user class as our first use case, we need to eventually refactor this thing to be way more reusable. So here's the general idea. We're going to build up class user. We're then going to refactor user to use composition to handle three different areas of functionality. And then finally, we're going to refactor user to be a very reusable class that we can use to represent anything like a blog post, image, comment, whatever, and not just a user. Now, the general idea behind this approach right here of building up something specific and then pulling something reusable out of it is what you might refer to as like an extraction approach. So we're trying to build up some like specific application to represent a user, and then we're going to extract some reusable library out of it. Okay, so now that you understand that, let's take a look at how we're going to actually build the user to implement these three pieces of functionality. Okay, complicated diagram here. So this is kind of like the user mega class that we're going to start off with. We're going to build all this functionality directly into the user, and then we're going to eventually pull out certain parts of it and use composition. And then we're going to eventually refactor it again and make a very reusable class out of it that we can use to represent any type of data. So let's take a quick pause right here. When we come back in the next section, we're going to go through just a couple of these different properties that a user is going to have, and then we'll start the actual implementation. So quick break, and I'll see you in just a minute. In this video, we're going to start taking a look at some of the different properties that a user is going to have. So first off, a user is going to have one distinct piece of data called simply data. And this is going to be some object that stores all the different properties that describe a very particular user, such as their name, their age, and so on. Now notice that I've marked this property right here as being private. Remember, that modifier means that we cannot access that data property from outside this class. So the whole idea here is that we don't want other developers kind of reaching into a user and messing around with its data manually. Instead, we want our different developers who are going to use our framework to eventually use some other methods to manipulate the data. Those two methods are going to be called get and set. We are not going to use Typescript's built-in getters and setters in this particular application, and there's a very good reason for that we'll discuss later on through the implementation of this thing. So for right now, just understand that anytime that we want to change some data related to a user, we're going to use the get method or the set method. The purpose of get right here is to pass in the name of some property that we want to retrieve. So if a user has some data tied to it, like a name and an age, and we're calling them specifically name and age, we could retrieve the name by calling get and passing in a string of name. Oh, don't want to delete that much. Name, like so. And that would retrieve the name of a particular user. And then if they wanted to get the age of a user, we would pass in age like so. So because get can return different types of data, notice how I annotated the return type of get right here as returning either a string or a number. This is not going to be a long-term solution right here. We're going to eventually have a long discussion about that return type and how we can kind of improve it, but we'll get around to that later on. So then to change any data related to a user, we're going to have a set method. The set method is going to take in some object that describes how we want to update information about a user. So for example, if we want to update a user's name, we would pass in an object that had a name property and the new name, like my new name, like so. And if we wanted to update the age of a user, we would pass in an object with an age property and then the new age, whatever that might be, like so. Okay, so those are the first three things we're going to focus on. We're just going to focus on making sure that we have the ability to create a user, like an instance of a user class, that a user has some data tied to them, and that we can get those different pieces of data and eventually change them as well. So now that we understand the first goal that we're going to try to achieve, let's take a quick pause right here and then start the implementation in the next video. In this video, we're going to start implementing our class user and giving it the data property, get, and set as well. So let's get to it. I'm going to begin by flipping back over to my code editor. Inside my src directory, I'm going to make a new folder called models. This folder is going to eventually hold all the different models of our application, or essentially all the different classes that represent some data. Then inside of models, I'm going to make a new file called user.ts. And inside of user.ts, I'm going to export class user, like so. So the first thing we said was that this thing is supposed to have some data property tied to it. And that data property is going to actually represent the information about some particular user. It would be really nice if we could assign some properties to a user when we first create an instance of it. So in other words, it'd be really nice if we could say like new user and then right away pass in an object with this user's name and their age, whatever it might be, like so. So we not only want to have a data property tied to a user, we also want to be able to specify that data property when we create an instance. So that means that we should define our constructor function and make sure that it can receive a first argument that is an object that looks like this right here. And we would need to take that information and assign it to some property on the user. Okay, so I'm going to define my constructor. I'm going to give the first argument a modifier of private, because remember, we don't want other engineers reaching in directly to our class and modifying data. I'm going to say that this property is going to be called data, and then I'm going to put in a type annotation for that object we were just looking at. So it has to be an object with a name that's a string and an age that is a number. So we could express that in a type annotation by writing out an object and name that's a string and age that is a number. Now remember, we discussed this type of annotation much earlier inside the course, and we had said, you know what, writing out a type annotation for an object literal directly in line like that is really not the best thing in the world, because it means that, well, if we ever add in more properties, we're just going to have to add them on to this line, and the line is going to get longer and longer and longer. So one way to save space is to extract that definition of that object right there into an interface instead. Remember, interfaces are not only used to somehow get some amount of code reuse between different classes, they are also used to create types that describe object literals. So let's create an interface at the very top, and I'm going to call it user props. So the purpose of this interface is to essentially describe that type right there, the different properties that a user is going to have. So it's going to be a name that's a string and an age that is a number. And now we can delete that long form type annotation right there and replace it with only user props. And then finally, after the constructor, I'll put in my curly braces like so. Okay, so that's a pretty good start. So now the next thing we want to do is make sure that this thing has a get method that we can use to retrieve some information off of that data property. Remember, we don't want other developers reaching into our user and messing around with the data property directly. There's a very good reason for that you're going to see in a little bit as we start to change and add some more functionality to our application. So I'm going to add in a get method to my user class. This thing has to be called with some property name, or prop name as we will call it, and that is the name of the property that we are trying to retrieve. So I'm going to receive that as an argument called prop name. It's going to be a string, and then from this, we're going to return either a string or a number, because someone who calls get can be requesting either name or age. So we're going to put in a type union right here. We can express a type union by using the parentheses and then saying name, or excuse me, not name, but number or string. Remember, that is a type union. It means that we're going to return either a number or a string from this method. So now inside of get, we can return this.data, and we will look up the property prop name, like so. All right, so that looks pretty good. So now in theory, we can actually test this out by exporting. Well, we already got the export right there. But we can flip over to our index.ts file. We can try to create a new instance of a user and then try to test out the code that we've written so far. So let's do that right now. I'm going to flip back over to index.ts. I'm going to delete the console log statement at the top, and I'm going to import the user from the models/user file. So then I can create an instance of a user, and I can pass in some initial properties for this user. So I can say, okay, first user is going to have a name of my name and an age of 20. And then if I want to retrieve one single property off the user, I could say user.get, and I can get their name, or I could do a user.get and get the age. And then to make sure that we can retrieve those correctly, I'll put in a console log for both of them. All right, so I'll save this file. I'm going to flip back over to my browser. I'm at localhost 1234 with my console open, and I can plainly see the name of the user and their age as well. Okay, so that looks pretty good. So let's take a quick pause right here. When we come back in the next video, we're going to make sure that we give our user class the ability to change that data as well. So quick pause, and I'll see you in just a minute. In this video, we're going to make sure that we have the ability to change the data that is tied to a user. So to do so, we need to implement a set method. Remember, when we call set, we're going to pass in some object that contains all the different updates that we want to make to our user. So the object might have a new name with a new name that we want to assign to our user, like so. All right, so I'm going to flip back over. And inside of my class user, I'm going to define a new set method. So when we call set, I don't think that we need to return anything at all. So I'll give this a return type of void. And then as my argument, I'm going to receive that as something that I'll call about just like update, because it is basically an update to the properties of this user. I guess that makes sense. And then this object can be, this argument can be an object that has a name that is a string or a age that is a number, because those are the two properties that we can possibly update on our user. Now, once again, we've written out a type annotation for an object literal right here. So we can replace that object literal type definition with the interface that we just defined instead. So let's do that just to save a couple characters. So I'm going to replace that type annotation with user props. Okay, so now inside of here, we're going to look at that update object and use it to update all the information that we have on data. We could do this by trying to iterate over the update object and taking a look at each property one by one. Or we can do this entire update in one single step instead by using a function built into JavaScript called object.assign. The object.assign method is going to take two objects. The second object that we pass in is going to have all of its properties taken and copied over to the first. And so that essentially does exactly what we are trying to do here. So we're going to say, take our this.data object. Remember, that is the object that records all the information about this particular user. And then we want to take the update object that we just passed in and pass it in as the second argument. So this basically says, take all the properties on update and all the values on there and just copy paste them over onto this.data and override all the properties on this.data. So whatever's on there is going to get overwritten and replaced, which is exactly what we want. Okay, so let's now save this. We can flip back over to index.ts and we'll try to write out some code to now make use of our new set method. So back inside of index.ts, I'm going to add in some new code right after we create our user to update the name and the age. So I'll say user.set, and then I'll pass in an object to update the properties of this user. So I'm going to say that I want this thing to have a new name of new name and an age of about 999. So we're going to create our user with one set of properties. We're then going to immediately update them, and then we will print out the name and then the age. So let's save this, flip back over to our browser, and test once again. All right, I can see new name and 999. Perfect. Well, almost perfect. You see, this actually has one little downside. Take a look at this. Back inside of index.ts, I'm going to try updating only one property. Chances are we're not going to always want to update the name and the age at the same time. We probably are going to more frequently want to update just the name or just the age. So what would happen if I try to only update name? Well, when I try to only update the name, I very quickly get an error message. So we can take a look at the error message, or I can just tell you what's going on. So here's what's happening. Back inside of user.ts, we said that the set method was going to be called with some object that conforms to the user props interface. And inside of our interface, we said that an object to satisfy this interface must always have a name property and an age as well. So the problem here is that if we want to only update one property, we no longer are conforming to that interface, and that means we can't just update one property at a time. So in order to fix this, we're going to make a little change to our user props interface. We're going to say that both the properties on here are optional. I can mark them as optional by putting a question mark after each of the property names, like so. So now this says, in order for an object to satisfy this interface, it can have a name, and it can have an age. But if it doesn't, that's totally okay. So now that we've made that change, we can save this file, flip back over to the index.ts file, and you will see that that error has now gone away. So the question mark makes a property optional. So we no longer have to provide both a name and an age when we try to pass in an object to set. We can provide just one or just the other. So like I can change this to age with an age of 999, or we can still do both. Technically, we can also do no properties at all. Now, that's actually kind of weird behavior, but it's not strictly forbidden. Like, this actually won't cause any issues inside of our code. It is weird, and we probably wouldn't want someone to do this, but nonetheless, it's technically not going to break anything, so we can allow that. All right, so now we've got a lot more flexibility. The other thing that is nice about having these optional properties on that object type is that when we create a new user, we do not have to initially specify a name and an age. So now that the name and the age on the user props object is optional, we can create a user without any properties, which actually would be very useful. For example, sometimes if we want to present a form to a user that asks them to sign up to our application, we might want to create an empty model and then have a user enter in an email and a password. So sometimes we do have to create some object like this without any initial values inside of it, and then only assign or initialize those at some future point in time. Okay, so this looks like a pretty good improvement. So I'm going to save this file. We'll take a quick pause right here, and we're going to continue working on our user class in the next video. We've now finished up our first part of class user. So we have the ability to have some information about a user. We can retrieve those properties and set them as well. So we're now going to move on to our second little part of functionality around our user, which is to make sure that whenever we change something about our user, we can notify other parts of our application. To do so, we're going to set up a little mini eventing framework of sorts. Now, when I use the term eventing in JavaScript, I'm talking about a very specific programming architecture, kind of a style. If you've ever worked with HTML before, you're probably very used to setting up event handlers. So inside of my JavaScript console really quickly, I'm going to get a reference to document.body, and I'm going to try to add an event listener to it. To do so, I can call add event listener, and then pass in the name of the event I'm looking for, like maybe a click, and then I can pass in as the second argument a function to run anytime that event is triggered. So then inside of this function, I can do like a quick console log and say, hi there or whatever else. So the whole idea here is that we are adding an event listener. We are watching for a very specific event to occur. And whenever that event occurs, our function right here gets invoked. The function right there is going to be invoked by the browser. So that is some like built-in functionality. So we want to set up a system just like this right here to work with changes to data on our user model. So it's going to be very similar to this add event listener type function. The only big difference is that we're going to call the function that sets up the event listener on. So rather than calling it add event listener, we're going to call ours on. The first argument is going to be a string of the event that someone is watching for, and then the second argument will be a callback function. Now remember, when we make use of browser-based events like click events, it's usually the browser that eventually says, oh, something was just clicked, I need to call all the callback functions that were registered. But in this case, you and I are building the actual framework. And so you and I have to build in the actual ability to say, oh, something just happened. We need to run all the callback functions related to some given event. And so you and I are also going to build a function called trigger. And this trigger function is going to run all the callback functions that have been registered by on. All right, so that's the idea. Remember, the entire goal of on and trigger right here is going to make sure that other parts of our application can react to some changes in our user data. All right, so now that we've got a better idea of what on and trigger are all about, let's take a quick pause right here and start implementing them in the next video. Now that we've got a better idea of what on and trigger are all about, let's start writing out an implementation for them right now. So I'm going to flip back over to my code editor. I'm still inside of class user. So I'm going to first stub out the on method and the trigger method and give them some working signature that we can kind of get started with. So I'm going to say that this class needs to have an on method. It's going to be called with some name of event that is a string. How about rather than calling this name, because that might get confused with our user name property, let's instead call it like event name. That's probably a little bit more clear. And then the second argument is going to be some callback function. So I'm going to receive that as an argument called callback. And then we have to write out a type annotation right here to indicate that this is going to be a function. So to indicate that this is going to be a function, I'll write down parentheses, curly brace, or excuse me, arrow curly braces like so. So that's how we indicate that callback is going to be a function. In this case, we are indicating that it is a function that's going to receive no arguments and return no value. We might eventually update that in the future, but for right now, this will work out just fine. Now, if this syntax right here looks a little bit nasty, we can create something called a type alias and essentially pull out that type annotation to somewhere else inside this file. Let's try that out right now, just because it might come in handy in just a little bit. So at the top of the file, I'm going to create a type alias for a empty function, or essentially a function that has no arguments and no return value. So to do so, I'll write out type, then the name of this type that I want to create. I'm going to call it callback, and then I'm going to write out the type that this is going to refer to. And so it's going to be a function that takes no arguments and returns nothing. So now rather than writing out this kind of function type right here, I can instead just refer to callback. Setting up a type alias like this right here for a function is really nice because when you start to write out arrow functions inside of your actual implementation code, life gets kind of confusing really quickly. Some people might look at this and say, oh, callback like is this function right here. Why is it an empty function? Well, that's not a function. We're not creating a function there. That is a type annotation. We are saying that callback is going to be a function with no arguments and no return value. So creating a type alias like this helps to add just a little bit of clarity to our code. So now down here, rather than putting in that type annotation, we can instead refer to the type alias we just created by saying callback. Okay, so this right here, all we're saying, we are going to call on with a string as the first argument and a function as the second. That's it, nothing more. Okay, so now here comes the kind of hard part. We need a way to store all these events. So when we call on, we're going to pass in the name of the event that we are listening for. You and I do not really yet know the different names of events that we might have. You just saw a moment ago inside of my browser console, I showed you an example of attaching a click event handler to the body element. So as the first argument to this thing, I passed in click. So that meant that I was watching for the click type event. There are many other types of events that we can listen to that are built directly into like normal HTML and JavaScript. So we can also listen for, say, a hover event, or I don't know, a drag event, or a mouse up or a mouse over or whatever else. These are all different types of events that we can listen for. So we need to make sure in a very similar fashion that our on function has the ability to receive many different types of event request listeners. So we need to be able to receive all these different strings and kind of like hold on to them all or kind of catalog them and get them ready to be called at some future point in time when we actually want to trigger this event. So that's going to be just maybe like a little bit confusing. So let's take a quick pause right here. We're going to come back to the next video and I'm going to show you a diagram to really help you understand what we're trying to do here with this next step and show you exactly how we're going to solve this thing. So quick pause and I'll see you in just a minute. In the last video, we left off on this on function right here, and I kind of cryptically said, oh yeah, we need to have support for different kinds of events. So in other words, when we create an instance of a user, we're going to want to be able to add a bunch of event listeners. And then only at some future point in time are we going to want to actually trigger or actually run those different event listeners. So we need some way to kind of store all these callback functions until it's time to actually call them. So to do this, we're going to use an object to store all the different event names with all the relative callbacks. Let me show you a diagram that I think is going to really clarify what I'm talking about here, because it's kind of tough to put into words. Okay, so here's the general idea. Inside of our class user, we're going to create an object that's going to store all the different event listeners that get added to a user. Inside this object, we're going to have keys that are going to be the names of different events. You and I have not yet discussed the different event names that we're going to have tied to our user, but right now, we'll just imagine that we're going to have like similar events that are related to normal HTML events. So the keys of this object are going to be event names. Then the values are going to be arrays that store all the different callbacks that have been registered for each of these different events. So in other words, if some other developer makes use of our user and they call on with an event name of click and then pass in some callback and then do the exact same thing a second time, we're going to take both the callbacks they pass in, and we're going to add them to an array where the click property inside this object points at that array. When we eventually decide to trigger the click event, we will iterate through this array and call each of those callback functions. This is a pretty standard eventing style setup right here. So you'll actually see this kind of implementation with many other styles of eventing libraries in JavaScript as well. Now, in some cases, we might have some events that don't get any callbacks registered. So this would just be an empty array. We could still trigger the hover event, and we would just have no callbacks to run. And then same thing with mouse over. If we trigger mouse over, well, we will iterate through this array and call the one callback that has been registered. So that's the general idea. So let's try actually writing out some code to make this happen. All right, so the first thing we need is some property on our class user that's going to store all the different events that get registered. So I'm going to add a new property definition up here. We do not need to pass this in when we create an instance of our user, so I'm not going to add it to the constructor. We're only going to allow events to be registered after a user has been created. That's why we're going to add it in as a separate property. So I'm going to say that there's going to be some property called events on our user. Then we have to put in a type annotation here. Now the type annotation is going to be a little bit tough, so let's just write out the syntax and we'll talk about what it means. So I'm going to say events is going to be an object, and all the keys of this object are going to be strings. And then the value for each of those keys is going to be an array of callback functions. And then finally, I'm going to initialize this as an empty object like so. Okay, so what does this mean right here? Well, remember, usually when we write out a type annotation for an object, we just write out the name of the property that's going to eventually exist here. So we might, have something like, say, click or something like that. But in this case, we don't know the names of the different events that we're going to have. We have no clue. We might have eventually an event tied to a user called click or hover or mouse over, or maybe like change or sync or delete. The point is, you and I just don't know yet what the different event names are that we will have tied to a user. So to solve that, we're going to say, hey, Typescript, events is going to be an object. We don't know what the different keys are going to be. We have no idea whatsoever, but we do know that they will be strings. And all these different keys are going to point at values that are an array of callback functions. So we use this syntax right here anytime we are trying to tell Typescript, look, we just don't know what properties this object is going to have. We know it will be an object and that it will have some properties, but we just don't know. So now we can add any property we want to the events object and always point it at a callback or an array of callbacks. So for example, inside of on, just as a quick example, this is not the actual code we're going to write inside of here, but we can say this.events and then use the bracket notation and say like anything you can possibly imagine is going to be an array like so. It can be an empty array or, technically these are supposed to be callback functions. So we could put in like, say, an empty callback function like so. So we can continue adding more different properties to this object. And this is 100% allowed because we specifically told Typescript, look, we don't know what keys this object is going to have right now, but we will in the future. Okay, so that looks good. I'm going to delete that quick example right there. I'm going to save this file, we'll take a quick pause, and when we come back in the next video, now that we have somewhere to actually store these events, we will add them in anytime that we call the on function. So quick pause, and I'll see you in just a minute. In this video, we're going to start implementing our on method, but before we do, I want to take care of a couple of housekeeping items. First off, we defined the on method, but I neglected to put on a return type on here, so I'll make sure that I do that like so. I don't expect to return anything from this method, so I'll annotate it with a type of void. Next up, at the top of the file, I made a little typo here when I defined the type alias. I said that we were going to define a function type that takes no arguments and returns nothing. I used the incorrect syntax. The syntax we put right here is actually interpreted by Typescript as being a function that takes no arguments and returns an object. So when you put down those curly braces inside of a function annotation, Typescript thinks that we are saying, oh yeah, this is going to return an object of some kind. To actually indicate that we want a function that returns nothing at all, we would put in void like so. So that was a typo on my part. I apologize for that. Okay, so that's much better. So now we can get back to our on implementation. Okay, so inside of here, we're going to have to handle two different cases. Remember, I just told you at great length how the events object, when it gets initialized, when we first create our user, is going to be an empty object that's going to eventually have some keys as strings, or strings as keys, and an array of callback functions. But when user is first created, we have an empty object. So there's actually two cases that we need to consider inside the on method when we start to think about registering a callback function. So inside of here, if we do this.events at event name, that can have two possible values. It can be either an array of callback functions, or it can be undefined. So when we first create our user, this line of code right here is guaranteed to be undefined. But as we start to add in some actual events here, eventually some of these keys might give us back an array of callback functions. So we need to basically just handle both cases appropriately. So to do so, here's what we're going to do. I'm going to say const handlers is going to be this.events at event name or empty array. That's the trick. So when we first create our user and we look at this.events and look up event name, that's going to give us possibly undefined. If it does, then we will just fall back to assigning an empty array to handlers. But if this.events is defined, or excuse me, this.events at event name is defined, then we'll take that array of callbacks that we've already created and assign it to handlers instead. Either way, handlers is guaranteed to be an array. So after we get that array, we can then say handlers.push, and we'll add in the brand new callback that was passed into our on method. So I'm going to push in callback. And then finally, we're going to take the handlers array and assign it back to the this.events object. So we'll say this.events at event name is handlers like so. And that's it. Okay, so let's now give this a quick test. Now, when we test this, we don't actually have the ability to invoke any of these handlers just yet. We only have the ability to just register them right now. But that's fine. We can still write out some code to make sure that they are being registered correctly. So back inside my index.ts file, underneath our user declaration right here, I'm going to delete the user.set and the console logs. I'm then going to register a new event with my user. So I'm going to give it an event name of like change. It honestly doesn't matter. We can register any event right now that we want to. There are no meaningful events inside of our application yet. And then I'll pass in a callback function. The callback function doesn't have to do anything at all right now because once again, we don't have the ability to trigger any events. So to actually make sure that something here is actually working correctly, well, we can just look at our entire user through a console log. We can look at its events property and just make sure that it has a change property on there with at least one registered function. That's how we can test that this thing is actually working. So I'm going to save this file. I'm going to flip back over to my browser. I see the console log of user right here. So there's the events property. I can see that it has a key of change and it has one registered function with it. So we're definitely registering functions correctly. We can now try to register a second function. So I'll add in a second one. I'll say like user.onChange a second time. And then just for fun, I'll try registering some other event name as well, like so. Okay, so I'll save that again. Flip back over. And now my user events object has that random key. It also has the change property with two functions in there. So now in theory, if we had the ability to trigger some event, like trigger the change event, we would look at this array of functions right here and run each of those functions. Okay, so this looks pretty good. So let's take a quick pause right here. When we come back in the next video, we're going to do exactly that. We're going to make sure that anytime we call the trigger method, we can pass in the name of an event, and then we'll loop through all those different callbacks and call them. So quick pause, and I'll see you in just a minute. All right, in this section, we're going to make sure that our model has a trigger method assigned to it. Once again, this is going to allow us to trigger all the different callbacks registered to some particular event. As a quick reminder, we don't have any special events inside of our application yet. We're building out this system first, and we'll very quickly see why we are adding in this functionality in just a little bit. Okay, so let's get to it. So inside of my user class, underneath on, I'm going to add in a new function called trigger. We're going to call this thing with some event name, and that's going to be a string. I don't expect this function to return anything, so I'll give it a return type of void. So now inside of here, we first need to see if we have some registered events with this given event name. So I'm going to pull off that array of callbacks. I'm going to call it handlers again, and I'll say this dot events at event name, like so. So now remember, events right here at event name, that can be an array or undefined, one or the other. So we need to check to see if handlers is actually defined and if it is an array. So to do so, we're going to say if there are no handlers, like if that variable just doesn't exist, if that is undefined, or if there are no handlers inside there, so handlers.length equals 0, then we will just return early. So then if we do have some defined handlers array, and we do have some number of handlers in there, then we will call all those callbacks right after we have that early return. So to do so, we can say something like handlers.forEach, and we'll say for each callback inside there, just run the callback. And that's pretty much it. All right, so I'm going to save this. Now we can do a real test of the whole eventing system. So I'm going to flip back over to index.ts. We've already got some registered events on here, but now to make sure that they're actually working correctly when we trigger an event, we need to make sure that these callback functions actually have some implementation on them. So on the first one, I'll add in a console log of change number 1. On the second one, I'll add in a console log of change number 2. And then on this last one, I'm going to give it a more reasonable name. I'll call it something like, I don't know, save. Maybe we have an event called save for some reason, who knows. And inside there, I'll add a console log of save was triggered. And then finally, instead of the console log at the bottom, I'm going to delete that console log. And now we can try calling trigger and triggering a change event or a save event. So I'll call user.trigger change. And that's how we would use that. Okay, so now I can save this, flip back over, and I should see 2 console logs. Yep, sure do. Change number 1 and change number 2. Likewise, I should be able to trigger a save event. So I'll change to save. Yeah, that makes a lot of sense. Save that, flip back over, save was triggered. And then finally, we will test the case in which we are trying to trigger an event that has no callbacks whatsoever. So like some random event name like so. So I'll save that, flip back over, and we get nothing at all. And most importantly, we didn't get any crashes either, which is good. All right, so this is looking pretty great. So we've now completed our eventing system. So now the last thing we are going to work on that is tied to a user is an actual syncing system as well. So we need to have the ability to make sure that we can fetch some data from some outside server about a user and also save some data about a user as well. So quick pause, and we'll start to take care of those in the next video. Now that we've finished all of our eventing stuff, we're going to move on to the last piece of functionality around class user, which is the ability to save information to some backend server about a user and then fetch it at some future point in time. Now, when we talk about saving information or fetching it, we're really talking about that data property. Remember, the data property of a user stored the name and age of a user. So I want to have the ability to save information about a very particular user to the backend and then eventually fetch it at some future point in time. Now, to actually save and fetch information, we of course need an actual backend server. So we're going to have to very quickly implement a backend server. Don't worry, it's going to be really fast. We're going to use a third-party package that's going to be just perfectly tailored for what we are trying to do here to host our server for us. So here's the idea. Here we go. Inside the browser, we're going to have our user instance, like the class user we are working on right now. This user instance is going to be making use of that Axios library that we saw much earlier on inside the course. Remember, Axios can be used to make network requests to some outside server. So whenever we try to save some data, Axios is going to make a request to this outside server that you and I are going to set up. The package that we're going to use to set up this server is called JSON server. This is a third-party package that we can install via npm to stand up a server very quickly and very easily. It has the ability to receive information and store it into a plain JSON file, and then eventually serve that information right back to us. So once again, it's a really easy way to get a server stood up in a development environment. So let's try installing that package and then going through a little bit of setup with it and getting a better idea of how this JSON server is going to work. All right, so back inside of my terminal, I'm going to find where I'm currently running Parcel. I'm going to stop this process with Control-C, and then I will install JSON server, with npm install -g json-server. Okay, so we're going to install this as a global module. Just installing it isn't quite enough. We also have to do just a little bit of setup inside of our project directory. Whenever we run JSON server, we have to point it to an actual JSON file, or a file that contains some amount of JSON data. This file essentially acts as a database of sorts. So that file is going to be where JSON server attempts to save all of our information about various users inside of our app. So I'm going to flip back over to my code editor and create a JSON file that's going to serve as the database for our JSON server. Okay, so back inside my editor, I'm going to create a new file inside of my root project directory. Make sure you are creating this file inside of your root project directory as well. And I'm going to call it db.json. So inside of here, we're going to eventually see a ton of data appear. And all this data is going to be information that we are trying to save about the different users inside of our application. We're not going to, in general, write any information into this file manually, except for right now when we do some initial setup. All the data inside of here is going to be managed by JSON server for us. So the initial setup that we're going to do inside of here is going to be to create an object. I'm going to add in a key wrapped by double quotes called users, and I'm going to give that a value of an array, like so. Make sure you have double quotes around users. If you don't have those double quotes, this is not going to work correctly. So now when we start up JSON server, we're going to point it at this file. JSON server is going to look at this object right here, and it's going to see that it has a key of users. So that tells JSON server, oh, okay, it has to serve up a resource called users. And JSON server is going to automatically create a handful of different routes that will allow it to serve us some JSON data about users. It will give us the ability to save users to this backend database as well, and then fetch them at some future point in time. So I'm now going to save this file, and then to actually start up the JSON server, I'm going to go back over to my terminal. I'm going to open up a second terminal window, also inside my project directory. Inside the second one, I'm going to run json-server-w and then db.json. Let me resize this thing just so you can see the whole command very easily. Okay, so we'll run that, and then we'll see a message appear like so. So under this resources section, notice how it says /users. So JSON server has parsed that db.json file, and it understands that it's supposed to serve and receive requests around some resource called users. Now that doesn't really quite tell us what that, give us like any functionality right now, but we'll talk about what that means in just a moment. First, I'm going to go back over to my first terminal window. Over here, we just spoke about how we need Axios to communicate between our user model and that server. So inside of my project directory, I'll do a quick npm install for Axios. And then after that is installed, I'm going to start parcel back up with parcel index.html. Okay, so that looks good. Now at this point in time, we have two different commands to actually start up our project. If you ever stop either of these running processes, you're going to have to start up two terminal windows. One is going to run parcel index.html, and the other is going to run JSON server-w db.json. Now it's really easy to forget these commands. So to help us, I'm going to flip back over to the package.json file, and I'm going to create a script to run that command and that command. This step is entirely optional. I just want to do this so that if you ever stop these running processes, you don't have to come back to this video to remember what to run. So I'm going to go to my package.json file. I'm going to add a script section inside of here. And I'll add in a script called start:/db. And if I ever run this, I will actually execute json-server-w db.json. And then right after that, I'll do start:/parcel. And if I ever run that script, I will do parcel index.html like so. Oops, I forgot a comma right above scripts. There we go, that's better. Okay, so now as you watch me in this course, I'm generally just going to run these commands directly because I know them off the top of my head. But if you ever forget them, just come back to the package.json file and you can use these as a reminder of what command to run. Or alternatively, at your terminal, you can now just do npm run start:/db and then a second window npm run start:/parcel. Totally up to you. Okay, so we've now got our JSON server up and running. So let's take a quick pause right here. When we come back in the next video, we're going to discuss how we interact with this server because it's going to very deeply impact how we actually design our user model to save and fetch information. So quick pause and I'll see you in just a minute. In this video, we're going to get a better idea of how to interact with our JSON server. As I mentioned in the last video, the JSON server is going to have a big impact on how we design our user class. Now, before you start thinking that we're going to design our user to only interact with the JSON server, no, don't sweat it. It turns out the JSON server follows a lot of very popular conventions for working with individual records of like JSON information. And so in the future, we could very easily swap out our JSON server and replace it with any of other implementations. For example, like maybe Ruby on Rails or something like that, or some Express server. And as long as those servers follow the correct convention, it's going to work with our user class just fine. So to get a better idea of how these conventions work, we're going to write out a little bit of code to interact directly with the server and take a look at one or two quick diagrams. Okay, so diagram first. All right, here we go. So right here on the screen are what we call RESTful conventions. These are conventions for making network requests to some outside server, and based upon the type of request or the method of the request and the path that we make the request to, it's going to affect exactly what that backend server is going to do for us. So these are the conventions that JSON server follows. And if we just follow these conventions, we're going to have the intended impact every single time without doing any additional setup of the JSON server. So in this example, I want to imagine how we would work with some resource called posts. So maybe we've got our backend server or the JSON server that manages a list of posts for us. If we wanted to retrieve all the different posts being served by that server, we would make a GET request to our server /posts. Right now, our server is running on localhost 3000, so in total, this would be something like that. But in general, when we are talking about these RESTful conventions, we are only concerned with the path on the very end. If we ever wanted to get a very particular resource or like a very particular post, we would make a GET request to /posts/ and then the ID of the post we are looking for. If we want to create a new thing or a new post, we would make a post request to /posts, and we would also include the JSON information for the post we're trying to create. If we ever want to update a post, we'd make a put request to /post/ID. And if we ever make or want to delete a post, we would make a delete request over to /posts/ID, where again, the ID is the ID of the post that we're trying to delete. So JSON server follows all these conventions right here. Just to figure out how they work really quickly, let's write a little sample code inside of our editor. We're not going to worry about working with Axios, or working with our user model just yet. We're just going to interact directly with Axios. So to do so, I'm going to flip back over to my editor and find the index.ts file. And we currently have a little bit of sample code inside of here. I'm going to delete all this sample code. And instead, at the very top, I'm going to import Axios from Axios. So let's first try to create a new user. Remember, JSON server has already created an endpoint to handle users because we put /u or users right here inside of our db.json file. So if we want to create a new user, we could say axios.post. Then we would put in the URL that we want to make this request to. Remember, the JSON server is currently running on localhost 3000. So if we want to make our network request, we would make it to localhost :3000/users. So you can either copy that URL right there or just type it out. So I'm just going to type it out. And then as a second argument, we'll put in an object that represents the properties that this user is supposed to have. So to stick in form with our current user class, we would say maybe this user has a name of my name. I'm going to use single quotes here, bad habit. And an age as well. So now if I save this, it's going to automatically refresh my browser, and the browser should make this request to that JSON server, and the JSON server should create a new user with that name and age. So I'm going to save the file. I'm going to flip back over to my browser. In my Chrome console, I can open up my network tab, and then if I sort by XHR requests, I should see the request appear in here. And you'll notice in my case, I don't see it appear, so I'm going to refresh really quickly. There we go. Now I can see it perfectly. So we first see a request that is of method options. The reason that's there is because we are making a request to a URL endpoint with a different port on it. If you've ever dealt with CORS errors or cross-origin resource sharing, that's what this options request is talking about. For what we are doing here, it's really not relevant. So then the second request is the actual post request that we're trying to make. So if we click on that, we'll see the response we got back from our server. So our server said, okay, it has created a new record that has an age of 20 and a name of my name. And then here's something really critical to notice. In the response that we got back from the server, our user that we created was assigned an ID of 1. So with JSON Server, anytime that we create a new record, it automatically will be assigned a unique ID. We can now go back over to our db.json file, and if your code editor supports live reload, you should see the user inside of here. If you don't see the user inside there, then just close that file and open it back up. So we'll see the name of the user that was created, their age, and the ID of that user as well. So now if we want to, we could retrieve information about this user by using that ID. So for example, if I go back over here to my index.ts file, and if we follow RESTful conventions, which you'll recall, if we want to get some particular resource, we need to make a GET request to / the name of the resource / and then the ID. So if we want to get information about the user with ID 1, we need to make an axios.get request to /users /1. And then with a GET type request, we are not going to provide any information with it, so I'm going to delete that second argument like so. So now I can save this file again. I can flip back over to my browser, and I'll see the network request that was made right there. And so the server sent back some information that said, okay, we found a user, their age is 20, ID is 1, and name is my name. So all these other RESTful conventions are going to work identically. We're not going to go through all of them because I think you get the idea now. And honestly, if you're here in this course, I kind of expect you might already know a lot of this stuff that I'm talking about. Now, there is one extremely important thing to keep in mind here. As you can tell, that ID property that it gets assigned to a user when it's created on the server is super important. If a user model or like a user class that we have has an ID, there's actually a really important ramification of that. So if we ever have a user that has an ID property, that means that this user has been saved to our backend server, because we're going to say that IDs are only generated by that server. So if we ever see a user with an ID, that means that it must have a server-side representation. However, if a user does not have an ID, that means that this user must be brand new and that we've never saved it to our backend server. So that's how we're going to use our single user class and kind of differentiate between a user instance of a user that has been saved to the backend and one that has not. Okay, now the other big impact here is that we need to make sure that that data property on all of our users has the potential to have an ID as well. Right now, our interface for it inside of user TS says that the user property, data property right here, is only ever going to have possibly a name or a string. So we're going to have to update this and make sure that it's clear that this can also have an ID as well. Because if we ever try to fetch a user or we want to fetch a user, we have to put the ID inside there, and then we're going to use that ID to actually retrieve a user or save it or whatever else. Okay, so this has been good progress. Let's take a quick pause right here. Then we're going to start working on some methods to support saving a user and fetching them on our JSON server. So quick pause and I'll see you in just a minute. In this video, we're going to start working on an implementation of our fetch and save methods. So let's get to it. I'm going to flip back over to my code editor. The first thing we need to do inside of our interface user props is add in a new optional property of ID, and that's going to be a number. Remember, this ID is going to be tied to every user. If a user has an ID, that means that they have a saved backend representation. If they don't have an ID, that indicates that this model is brand new, and there's probably not some backend representation for them. That ID is also going to customize the requests that we make using Axios to retrieve or save some information. Okay, so now that we've got the ID inside there, I'm going to go down to the very bottom of my user class, and we're going to first define our fetch method. Now for fetch, I don't think that we need to really add in any arguments to this thing. And as far as the return type goes, well, I'm not sure that we really need to return anything from this either. So I'm going to say a return type of void. You might notice that back on the diagram we were just looking at, I said that we were going to return a promise. Well, it turns out that the return value from fetch and save is a little bit nuanced. So we're going to first just start off returning nothing at all. And you're going to see that start to change over time, but we'll eventually get there. Okay, so now inside of fetch, we need to make a request over to our JSON server. And we need to make sure that we attempt to make a GET request that has the ID of our user tied to it. So in other words, we need to do this one right here. We're trying to make a request to get some information about the current user with that given ID, and we need to make that request to /users/ and then the ID. Okay, so to do so, I'm going to first go back to the top of the file and import Axios from Axios. I'll then go back down to the bottom inside of fetch. And I'm going to say axios.get, and we need to make a request to that localhost /users/1. So I'm going to use a string template here because we do have to inject our ID for the current user. So I'm going to place a set of backticks, and I'll say http:// localhost 3000, and then a slash, and then we're going to put in users, and then we will inject our current user's ID. So I'm going to put in the $ curly braces, and then this.get ID. And I'll zoom out so you can see that whole line. Now this request string right here is really nasty, so please triple check this. If we start to test out this code and it just doesn't work, I can just about guarantee you probably made a typo inside this string right here. And one thing I want to point out, notice how we are using that get syntax right there. We access properties on our user by using that get method. Okay, so now writing that request line right there is going to return a promise. So we're going to chain on a .then statement. So we get some notice of when we get a response back from our server. The response that we get back, I will receive as an argument called response. This thing is going to be of type Axios response. And from this function, I'm not going to return anything, so I'm going to annotate it as void. Now you'll notice on here, we've got an error around Axios response. So I just know that type off the top of my head. Whenever we chain on the .then statement, the argument that we get back here, or this first argument, is of type Axios response. So this is an object coming from the Axios library that contains the response information that we got back from that endpoint. So I'm going to go back up to the top of the file, and I'm going to make sure that I import this type from Axios as well. So at the top of the file, in addition to importing Axios into this file, I'm going to also, from Axios, import the type Axios promise, like so. Okay, so now if we go back down, oops, sorry, not Axios promise, Axios response. All right, better, there we go, Axios response. Okay, so now if we go back down, that error is now gone. So now inside of response is the JSON data that we got back from our API, and that should contain the ID and the name and the age of the user that we just fetched. So inside of the .then statement, I'm going to take that information and set it on our user. And I can do that by writing out this .set, and we're going to take response.data, like so. Okay, so response.data is the actual JSON data we are getting back from our server. And we're going to take that big object that represents that user. It's going to essentially be exactly this thing right here. And we're going to just set it on our user model and update all of its current properties. And that should be it. Okay, so I'm going to save this right here. Now we don't quite have the ability to test this just yet too easily. So let's take a quick pause right here. We're going to add in just a little bit more code so that we can test this, and then we'll actually do a test. So quick pause, and I'll see you in just a minute. In the last video, we added in some code to actually fetch some information about a particular user and update our current user model using it. So now the last thing we have to do to actually test this out is make sure that we can eventually assign an instance of a user an ID, because it's that ID that's going to actually tie a model or an instance of a user to some record on our backend server. So to do so, I'm going to flip back over to my index.ts file. Inside of here, I'm going to once again delete everything inside of here. I'm going to import my user from the models user file. And then to get started, I'm going to first create a user, and I'm going to give it an initial starting ID when I create it. So I'm going to say const user is new user, and I'm going to say, okay, this thing's ID is 1. So I've now created a new user that has an ID, and that indicates that this record right here has some backend representation, and that we should be able to make a request to our backend server and kind of fill in the information about the user. Now you might notice this kind of introduces a chicken and the egg problem with our application. We are saying, oh yeah, you can't fetch information about a user until it has an ID, but then simultaneously you kind of ask yourself, how are we going to know what ID to put in here? Don't worry, we're going to kind of solve that in the future. For right now, I just want to make sure that we can hard code or just physically throw in an ID on a user, and then have our user instance right here use that ID to actually make a request and fetch some information. Now, one other thing I want to mention really quickly, we are only able to pass in an ID here now, because remember, inside of our constructor of user, we are taking in that entire first argument and assigning it to the data property. So our data property is going to have that ID, and then down inside that request that we just authored right here, when we made the request, we said, oh yeah, look at the data property essentially through the get method and get that ID. So the ID is now like kind of being passed through all the way here to fetch. Okay, anyways, let's come back over here. So after we create the user, I'm then going to do a user.fetch. And I'm just going to basically like kind of leave it there, to be honest. We don't really have any mechanism yet to kind of get a notice of whenever we successfully fetch data. Remember, inside of fetch, we are not returning anything. We're not returning this promise right here. So we don't really have any good way of saying, hey, we've just fetched some data about a user, and here it is. We could, of course, add in a console log to this thing, but as far as our index.ts file goes, we don't really have anything or any mechanism to get some notice of when fetch has been successfully completed. So obviously, that's kind of a shortcoming that we're going to have to deal with in a little bit. But for right now, we can at least just look at our request log and make sure that the request to fetch information about the user with ID 1 is actually being issued. Okay, so anyways, I'm going to save this file. I'm going to flip back over to my browser, and I should be able to refresh, and in my network request log, see a GET request with an ID of 1. And yep, there it is. So now in theory, this user model, after completing the fetch request right there, we should be able to see our given properties on there. If we really want to test this, one way we could fix it is to do, like, just honestly, this is going to be a total hack, but we could set up a set timeout. We'll just do that to make sure everything's working. So I'm going to call set timeout, pass it a function. I'm going to give this a timeout of like 4 seconds. And then inside there, I'll do a console log of user. So by the time this console log gets executed, we should have already completed the actual network request inside of fetch. And so we should see the actual information on our user instance. Okay, so I'll save this, flip back over, and then after 4 seconds, I should be able to expand data and see age and name on there. Awesome. So just to make sure you understand why that's so significant, when we created our user model back over here, we didn't provide it a name or an age. The name and the age was extracted or essentially obtained by the user model itself by just using that ID and calling fetch. All right, so this looks good. Definitely a step forward. So we'll take a pause right here. When we come back in the next video, we're going to move on to our next piece of functionality around these network requests and make sure that a user model has the ability to save itself to that backend server as well. Because right now we're just working with one user that we had created inside of our db.json file by manually making a network request with Axios like 2 videos ago. So quick pause, and we'll take care of save in the next section. In this video, we're going to work on our save method inside the user class. So I'm at the very bottom of the user.ts file. Here's the fetch method. Right underneath it, I'm going to define save as well. Now, just like fetch, I don't think that save really needs to return anything just yet. So I'm going to give this a return type of void like so. And then in addition, I don't think it really needs any arguments either. So yeah, I'll leave those off too. Okay, so now inside of save, it's not going to be quite as easy as just making a network request. You see, there's actually one consideration we need to have. When we start to think about saving data tied to a user, there's actually 2 scenarios we have to worry about. Remember, we had said that there really is a very strong responsibility of that ID property. If a user has an ID, that means that a representation of this user already exists on our backend server. So that means that if we are trying to save a user that has an ID, we are trying to update an existing record. And remember, we just spoke about those RESTful conventions. If we are trying to update a record, we want to make a put request to /users/ and then the ID and attach all the update information along with it. However, if a user does not have an ID, that means that this must be a brand new user. They're not persisted on the server, and so when we make this network request, we want to create an entirely new record. And if we are following our RESTful conventions, that means we have to make a post request along with all of our information about this particular user. So in other words, inside of our save method, we have to check to see if our user has an ID. If they have an ID, we're going to make a put request. If they don't have an ID, we're going to make a post request instead. Okay, so with that in mind, I'm going to flip back over and we're going to put our save method together. So inside of here, I'm going to say if this.get ID, then we need to do a put. Else, we need to do a post. And that's pretty much it. Okay, so let's try taking care of our put request first. So I'll say axios.put, and I'm going to use a template string here again. I'm going to make a request to http://localhost:3000/users, and then we want to put in the ID of the user we are trying to update right here. So I'm going to say, once again, this.get ID. Now, right away, you'll notice that we've got a duplication of this.get ID. So I'm going to just extract that up here. I'm going to say const ID is this.get ID. And now we don't have to have the duplicated function calls. So I can update the if statement to if ID. And then inside of our link right here, I can say simply ID. All right, so that looks good. So now as a second argument, we're going to pass in all the information about this particular user. So all the information is essentially that data property. Remember, that data property alone has all the custom information about this very specific user. In this case, very simply the name and age. And so I'm going to pass in, as a second argument, this dot data like so. Okay, now I'm going to remove that put comment right there. I don't think we really need that anymore. And then we'll take care of the post case. So this is the case where we don't have a user yet, so we need to create one by making use of a post request. So in this case, I'll do axios.post. I don't need to use a template string this time because there's no ID that we are trying to refer to. So I can use a plain string here, and I'll go to http localhost:3000/users like so. And then as a second argument, I'm going to pass in all the information I want to send, which is this.data. Okay, so this looks pretty good. Now, one thing I want to mention here, something that I'm sure you can guess, we are currently hard coding this localhost string inside of our user class. So it's entirely likely, even almost definite, I would say, that this big URL right here is not always going to be localhost 3000. So at some point in time, we definitely are going to have to figure out a better way of handling the URL, but for right now, it'll work out just fine. Okay, so to test this out, there are two scenarios we have to deal with. First, we need to try to create a user that already has a backend representation. We then need to update some information on that user and then attempt to save it. And the second case is we're going to create a brand new user without an ID, give it some information, and then try to save it as well. So I'm going to save user.ts, and then to test out those two scenarios, I'm going to go back over to my index.ts file. Now back over here, I'm going to delete the user.fetch and the set timeout. So this right here is a user that already has a backend representation. So I'm going to try to update some information on the user, like set a new property on it, and then I'll try to save it. And once I save it, I should see my db.json. I should see this record right here change. So notice how currently I have a name of my name and an age of 20. So I will expect to see those two records change once I save my user. Okay, so right here, I'm going to do a user.set. I'm going to set the name. I'm going to set the name to something like new name, just to make sure it's really obvious. And then I'll also update the age as well, like so. Now remember, I just did these in two separate set statements. You don't have to do that. You can do the combination or the update in both, or in just like one single line like so. And actually, just to be clear, I'm just going to stick with that route. Now, another thing, I just realized I didn't actually change the age there, so I'm going to put it to like some really big number like so. Okay, so now that I've updated this user, and this user has an ID, I should be able to call user.save on it, and then save this file, let my browser refresh, and then I should see an update inside my db.json file to that existing record. So I'm going to save this. I'll flip back over to my browser. I should see a put request, which indicates that I am updating a record. So that right there is the response that I got back from the server. And that means I should be able to go to my db.json file and see the new name and the new age. Perfect. So now the next thing we need to test out, we need to make sure that we have the ability to create a new user without an ID. And if we try to save it, it should create a brand new record inside of db.json. Okay, so I'm going to delete the user.set, and I'm going to change my user constructor. So I'm not going to give it an ID, but I will give it a name of new record and an age of, how about 0 this time? So in this case, we're creating a brand new user, doesn't have an ID. That means it doesn't have a backend representation. So we should be making a post request to create a brand new user on our backend. So I'll save this, flip back over to my browser. Yep, there's the post request. Go to my db.json file, and I should see a new record inside of here with the name of new record, an age of 0, and an ID of 2. Awesome. Okay, so this is looking pretty darn great. So we now have the entire spectrum of abilities tied to our user. We've got the ability to represent properties of a user, so we can get them, we can set them. We have some like eventing functionality here to set up callbacks and whatnot that we're not quite using just yet, but we will in a moment. And then we've got the ability to fetch data tied to a record or a user and to save information tied to a user as well. So this is looking pretty great. But at this point in time, we haven't really written a lot of brand new TypeScript just yet. I guess we kind of have. We've learned a couple things, but you know, as we're going through this, it definitely feels like, as we mentioned earlier, we're kind of creating a mega user class of sorts. Remember, that's what we spoke about earlier on. I told you we were going to build up this like mega user class. And that's what we are definitely at right now. We've got a user class that does a lot of very, very different things. So I think that we're at a really good point. But right now, I want to try to start refactoring our user to instead make use of composition. So just to give you kind of a different flavor on how we could potentially build up this user by generating separate different objects for each of the responsibilities that a user currently has. So let's take a quick pause right here and come back in the next section and start doing our first big refactor. All right, my friends, we've got a great implementation of our user class put together. And now in this video, we're going to start to, well, tear it apart. So I want to take our user class and refactor it into some pattern that tries to use composition to add in functionality to it. So the big issue with our user class right now is that it's got a ton of different functions that do very different things, which is kind of okay. Remember, we had said that was kind of like the initial goal of our user right here. It had these 3 very big responsibilities. But I just want to try to refactor this thing using composition. And I essentially want to extract that behavior into a separate class, that into a separate class, and that into a separate class as well. So I want to have one class that's going to be responsible for storing data related to a user. I want to have another that's responsible for all that eventing logic, and then one more to handle the actual like persistence of data and whatnot. We're still going to tie all these different systems together inside the user class, but the actual functionality is going to be completely delegated to these outside objects. So to see an example of this, the easiest place to get started is going to be that eventing logic we put together. So the on method and the trigger method. Nothing else inside of our user class is calling those 2 methods right now, so it should be really easy to extract them into some separate class and then wire them somehow back into our user. So let's get to it. All right, so I'm going to flip back over to my editor. Inside my models directory, I'm going to make a new file called eventing.ts. So the goal of this file right here is to implement a class that's going to be responsible for handling all the different events tied to a user. We don't have any events right now, but we've got the on and trigger methods. So inside of here, I'm going to export a class called eventing. I'm then going to go back over to user.ts. I'm going to find the on method right here. I'm going to cut it and paste it into eventing. I'm then going to go back over. I'm going to find trigger. I'm going to cut it. And I'm going to paste it inside of eventing as well. Now, right away, you'll notice we've got a lot of errors inside of here, so we got to fix a couple things up. The first big one is that we've got a broken type reference right here of callback. So remember, we had set up a type alias for that. We define the type alias inside of user.ts. So I'm going to flip back over, fix up some white space, and then at the top of the file, I'll find the type alias that we had added right there. I'm going to cut that type alias, flip back over to eventing.ts, and paste it at the top. Next up, we clearly have an error on here around events as well. So we had to find events as a property on our user class. So now I want everything tied to handling events to be tied to class eventing. So I'm going to go back over to user.ts. I'm going to find where we defined or declared that events property. I'm going to cut it out and then paste that inside of eventing as well. Let me collapse that sidebar just to make this a little bit easier to see. Okay, so believe it or not, well, that's pretty much it. So we've now extracted everything around handling events into a separate class. So I'm going to save this file, and I'll go back over to user.ts. So now here's the key. We want to make sure that whenever we create a user, we have the ability to essentially throw in some module or some class or some object to use for handling events. So let's take a quick pause right here. Now that we've extracted all that eventing logic, we're going to figure out how to wire it back in to our user. So quick pause, and I'll see you in just a minute. Now that we've extracted our class eventing, we need to somehow wire it back into our user.ts file, or specifically the user class. So let me first give you a quick overview of what this class is going to eventually look like. So our end goal here through using composition is to have our class user, and rather than having a ton of methods inside of it, we want to have a couple of different properties that class user can use to delegate out some very important operations. So we just extracted out some like eventing class, and now we want to eventually assign it back to maybe some property on class user called events. And then hopefully we will eventually have some attributes property and sync property to take care of handling properties tied to the user and take care of all that server saving stuff and whatnot as well. So we're not only talking about like integrating back in this eventing class, we eventually need to integrate back in attributes and something to handle sync as well. Okay, so with all this in mind, I now want to give you a quick reminder of how we handled this on a previous project. So I'm going to pull a code editor on the screen really quickly. All right, so this is from that CSV project we worked on. Remember, this is our match reader file. The match reader made use of the CSV file reader. So we made use of composition very heavily on this project to get some amount of code reuse. Remember, CSV file reader had all the logic of how to open up a CSV file and extract some plain text out of it and then do some very basic parsing on that text. So our whole idea here was that when we created an instance of match reader, we would pass into the constructor some property or some object that satisfied the data reader interface. So whenever we created a match reader, we could pass in a CSV file reader, or maybe like a network API reader instead. So we can very easily customize where match reader gets its information from just by passing in a different argument to the constructor. Now, to save a little bit of typing and avoid having to say basically that exact line right there every time we wanted to create a match reader, we had created a class method. Remember? The class method we called from CSV. And that essentially gave us back a pre-configured copy of match reader that already had a CSV file reader loaded into it. So now when we start talking about assigning that eventing class back into user, we essentially have to ask the same kind of question. How are we going to really get that eventing class into the user? Well, I think that there are a couple different options. This is not quite as easy as a decision back on match reader for one really important reason. All right, so I'm going to go back over to my real code editor. Here we go. So the reason that it's slightly different this time around is that we already have a constructor, and the constructor is going to take in some user information or some data about this user. So if we're talking about providing some dependency to the class through the constructor, well, we're going to kind of have to work it in with some existing code. So to take a look at a couple of ways of handling this, we're going to look at 3 different options in this video. So I'm going to quickly write out 3 different ways of handling this, and we'll just kind of do some like analysis on each one and decide which one might be the best for us. Okay, so I've copy pasted the code inside of user TS into these 3 separate files, and now I'm going to very quickly go through these 3 different options. Now don't write out any of the code I'm about to write. These are all temporary files. I'm going to delete all of them, and then we're going to re-implement whatever we do back inside of user TS together in the next video. Okay, so the first option to wire eventing back into our user would be to still accept these dependencies as like just a second argument to the constructor. So the first argument is always going to be our user data, or kind of like the initial data for our user. And we're just going to say, okay, the second argument is going to be dedicated to taking in some dependencies to make our user work correctly. So as a second argument, we could say on here something like, let me new line this just to make it a little bit easier to read. So inside of here, I would say, okay, now we've got a private property called events, and this is going to be an instance of the eventing class like so. So now what that means is every time we want to create a user, I'm going to show you an example at the very bottom of the file. I would have to do something like new user is going to be some like starting attributes, maybe an ID or whatever. And then the second argument would be new eventing, like so. Now this right here, it just kind of feels nasty. Every single time we create a user, we have to create an eventing class as well. And that means that like when we start to refactor out some different pieces of functionality, we're going to have to add those on as different arguments. So I don't know, maybe this is just like not the best approach just yet. But I just want to mention that this could be an approach. So now the second way of doing this would be to only accept dependencies into the constructor and define a static class method to pre-configure user and assign properties afterwards. So this would be way more similar to the match reader example we just looked at. So we're going to say that the constructor is always dedicated 100% to receiving configuration or kind of like submodules for the class. So we're always going to make our constructors inside of our project 100% about receiving these kind of composable subclasses. Now, I don't want to use the term subclass right there because we're not talking about inheritance. I just mean to say we're going to receive in these other classes to make our class work correctly into the constructor. And the constructor will never really be about taking in some initial data or something like that. And so this just kind of clarifies the purpose of our constructor a little bit. So let's take a look at what that would look like. Okay, so inside of my constructor, I would say the first argument is always going to be something that I'm going to use for maybe like an events property. And that will be an instance of eventing. So then I can define a static class method to give me like a pre-configured copy. And I'll say maybe how about like from data or something like that. So then we'll take in some properties for the user as an argument to this class method. So I'll call this about data, and that needs to satisfy the user props interface. So then inside of here, I'm going to return a new, or excuse me, I don't want to return it just yet. I'm going to create a new user. I'm going to say this is going to be a new user, and I'm going to pass in a new copy of eventing like so. And then after I create the user, I'm then going to take that data argument. I'm going to take all the properties in there and set them on the user. So I'll say user.set data. And then finally, I will return the user. Now to really make this work, I need to add in a annotation right there to say it's going to return an instance of user. And then also I need to make sure that when I set that data, we've now lost the kind of declaration of the data property that we previously had inside the constructor. So I would have to separately define it or declare it as a property on the class right here. So I'd probably say like private data is going to be some object that satisfies user props like so. Okay, so that would be this kind of second approach. So I think that this approach is pretty good, but at the same time, having to do this user set data stuff right here feels kind of nasty. In this case, initializing a user with the correct set of properties that we get off of data, well, it's only like one line of code, but I think you can kind of imagine that we might have some more complicated classes in the future that require many lines of initialization. And so we would potentially have to like add in a ton of configuration inside the static class method. And if we ever wanted to have some other configuration option, like maybe instead of using the eventing class, maybe we had like a different eventing module called like really cool events. Well, if we wanted to use that, we would then have to duplicate our static class method, call this one like super events or, whatever it is. And then we would have possibly many lines of initialization code right here as well. And those would be easily duplicated between both the classes. So I don't know, this still doesn't really feel that great as well, but maybe it's at least an improvement over what we just spoke about, this option down here as well, where we had the first argument of data and the second as the actual dependencies to our class. Okay, so let's now talk about the third option here. This one might actually make a lot of sense in this case. So in this scenario, we're going to say that the constructor is still all about receiving user properties. So doing some like pre-configuration of a user. And then here's the important part on this option number 3. We're going to say that we're just going to hard code our dependencies into this class as properties. So inside of my actual class user, I'm going to say that this thing is going to have an events property that's going to be of type eventing. And I'm just going to initialize it right here on the same line. I'll say new eventing. So what does that do? Well, that means that if we now go down to the bottom of the file, so I'll go all the way down here, if I create a user, like so, and I pass in some initial data for it, maybe in this case just an empty object, this thing is going to have a pre-configured events module inside of it. So events is already here. I don't have to do any further configuration. Now the downside to this approach is that we really lose out on some of the benefits of composition. Essentially right now, every time we create a user, we're going to have the same exact class serving as our events submodule inside of here. So back in our match reader that we were just discussing, remember we said that one of the big strengths of using composition is that we can swap out what source of information we are using on the fly. So back on this project, having the ability to swap out that submodule of sorts really quickly, it made a lot of sense. But on this project, well, you know what? Honestly, our eventing class, like this implementation right here is basically how all eventing modules or eventing libraries are put together. And I kind of have a really hard time imagining that we would ever want to replace our eventing class with some other alternate implementation. So on this project in particular, and most especially with this particular class, it kind of doesn't really feel that risky to just say, yeah, it's always going to be class eventing, because what else would it be? Like, what else are we going to put in here? What other copy of some eventing library are we going to use? Is there really such a big difference between different implementations of eventing libraries that we would ever want to swap this out? I don't know. I kind of have a hard time believing that. Now, even if we hard code this thing, we still retain some of the benefits of composition. We can very easily reuse that eventing class in other classes inside of our project. We can very easily test our eventing library in isolation because all this code is just right here inside of one file, and it's a self-contained class. So we still get a lot of the benefits of composition. We just can't easily swap out eventing on class user. That's all. So on this project, as you might guess, we're going to go with option 3. Eventually, we are going to possibly have to swap some things out, and you'll see why in a little bit. But just because I really don't see us having to replace a lot of these different modules we're going to put together, we're just going to say that we're going to hard code them in here. Now, if we wanted to, we could always come back in and say like, okay, project-wide, we are no longer using eventing. We're going to use this new like super events library that we are just installing into our project. That is always an option. We could like replace this thing on a global level so every user has a different copy of events or some new eventing library. That's still an option. But again, at the end of the day, I just don't really see that happening. All right, so that's pretty much it. I just want to give you a couple of different options of how we can integrate these extracted classes back into a like central class. So we had the option number 1, just continue to accept these things as a constructor argument. Option number 2, only accept the submodule of sorts as a constructor argument and then do all the other configuration inside of a class method. And then finally, what probably makes a lot of sense for us, just say, yeah, you know what? It's hard-coded, so what? So I think this way will work out generally pretty well, although who knows? We might eventually have to change it, maybe even sooner than you would think. So let's take a quick pause right here, continue in the next video, and we'll continue extracting logic out of our user class. And oh yeah, we need to actually wire up eventing because we were just looking at some examples. All right, so quick pause, and I'll see you in just a minute. In this video, we're going to take our class eventing and reintegrate it back into our class user. So remember, we just described probably just hard coding the eventing library or events property on user. Probably going to make sense here. Now, as one side effect of this, I just want to mention that since we are hard coding on eventing, maybe it doesn't make a lot of sense to try to create an interface as we did previously. Remember, back on match reader over here, we had created interface data reader to describe what a dependency must do to serve as a kind of submodule for match reader in this composition style approach. So since we're going to hard code in this eventing module, I don't really think we need to create an interface in this case just yet. Maybe we will eventually, but I really don't think so yet. Okay, so let's get to it. Inside of user.ts, I'm going to import eventing at the top, like so. And then inside of class user, I'm going to say that this thing is going to have a public property of events that's going to be of type eventing, and I'll assign it a new instance of eventing like so. And that's pretty much it. All right, so I'm going to save this file. We're going to go back over to the index.ts file and just test it out really quickly. Now, when we test this out, like I'm very sure it's going to work here, but I want to test it out to show you something very important, something that's kind of awkward now. And this is kind of something that's not quite so great about this whole composition style approach. So before, when we had the on and trigger methods directly on our user, we could simply say user.on and then change or whatever, and then pass in our callback function. But now that eventing module is nested on the user property. And that means that if we want to call the on method, we have to call user.events.on. So is this bad right here? I don't know. It's definitely a little bit less helpful, I suppose, to have to refer to that nested property all the time. A little bit more verbose. I'll show you a way to get around that in a little bit. I just want to mention it really quickly. So now just to test this, I'll do a quick console log of change inside there. And then afterwards, we should be able to trigger user.events. See, I'm already making a mistake. User.events trigger change. So now I can save this file, flip back over to my browser, and inside of our console, yep, looks like we still have the ability to trigger events. Okay, so that looks good. So let's take a quick pause right here. When we come back in the next section, we're going to start extracting our second bit of functionality out of user and put it into a separate class to make use of the composition pattern. In this video, we're going to start working on another extraction of functionality out of class user. So we're going to try to create a new property on class user called sync, and that's going to be an instance of a class called sync. And this sync thing is going to be a class that gives us the ability to save and fetch information about a particular user from our backend server. So essentially, all we're really saying here is that inside of class user, here it is right here, we want to scroll down to the bottom. Here's the fetch method and the save method. We want to extract both these methods into a separate module. Now you're going to very quickly find that extracting these methods is going to be way more involved than the eventing stuff we just did. So this will be a really fun extraction. We're going to learn a lot along the way. So to get started, I'm going to first create a new file inside of my models directory called sync.ts. Then inside there, I'll define a class and export it called sync. And now right away, well, let's just do the same thing as what we did last time. I'm going to go back over to user.ts. I'm going to find the fetch method, cut it, and paste it over inside of sync. Then I'll go back over to user.ts again. I'll find the save method, cut it, and paste it inside of sync as well, like so. So now inside of class sync, I've got fetch and save. Now right away, there's a couple of errors around Axios. We could probably fix those up really easily. I'm going to go back over to user.ts one more time. At the very top, we've got a now unused import statement for Axios and Axios response. So I'm just going to cut that and paste it at the top of class sync, like so. Now just about half of our errors go away. And here's the thing, the remaining errors, well, this is where our source of trouble is going to come from. So take a look. We've now got an error around this.set. We've got an error around this.get, another one around get right here, and this.data and this.data. So a ton of code inside of class sync is now trying to refer to different properties that are only on our user class. So this means that we're not going to be able to do a very simple cut and paste job for class sync. Instead, we're going to very clearly have to have a very well-defined relationship between class sync and class user. Because class user cannot work correctly without sync, and sync very clearly cannot work correctly without class user. So to fix up these kind of dependencies that both classes have on each other, let's take a quick pause. When we come back in the next video, I'm going to show you a couple diagrams to lay out different options of how we can get these two classes to work with each other very nicely. In the last video, we started extracting class sync, but we very quickly ran into some issues. Our fetch method is trying to refer to this.get, this.set, and basically same thing for down here on save as well. So how are we going to somehow resolve these references to methods that don't exist on sync? Well, there's definitely many different ways to solve this. And in this video, I'm going to show you 3 possible ways we could solve this issue. One way is not going to really work out so well. The other 2 are definitely serious contenders. So let's get to it. Okay, so here's the real issue. Our class user is going to have a sync property that's going to try to point at an instance of class sync. So at some time, class user is going to receive a method call or some kind of request that says, hey user, save your data. Class user is not going to be responsible for that. Instead, we are making use of composition, and the way that we are implementing composition here is through delegation. So class user is going to delegate that save request to class sync. So on class sync, we're going to eventually call save. And the expectation inside of method save is that we're going to take some data from the user and somehow save it to our outside API. So now that we understand those kind of ground rules, let's talk about these 3 different ways to solve the issue. Okay, so here's option number 1. Option number 1 is going to be that anytime user gets some kind of save or fetch request, in this case, we'll talk about save for the most part, class user is going to pass all the current data properties over to save, along with some ID to use as well. So in other words, the sync class is going to get some function arguments of the ID that we're trying to save this record as, and the actual data to save to that outside server. Now this approach right here absolutely, positively would work. The big downside to it, however, is that class sync will now be configured to only work with class user, because it's going to have some argument on here that says specifically, look for some argument that satisfies the interface user props. So class sync is only going to work with class user, and that means we would have to have a separate class sync for every different type of data inside of our application. And it all is because we expect this data argument to be some object that has a very specific type. Now, of course, we could probably change that, and we could probably just say, oh yeah, data can be like anything or something. But remember, as much as possible, we try to avoid type any. So I'm sure we can probably think of a better solution here than that. Okay, so that's the big downside to option number 1. This definitely would work. However, it would really isolate class sync and mean that it only works with this one class right here. So let's take a look at option number 2. Now, option 2 is going to be a little bit complicated, but we can get through it. First off, I want to take a quick side note here and tell you about the terms serialize and deserialize. So what do those terms mean in general? Whenever you see the term serialize, we are generally talking about taking some data off an object and converting it into like some savable format that can be easily persisted. When we have an object inside of JavaScript or TypeScript, it's kind of hard to like take an object in memory and just somehow save it to the hard drive. So we almost always first convert that object into some other type of data, usually for our case with TypeScript and JavaScript into JSON. So when we talk about serializing something, we are talking about taking some properties off an object and converting it into JSON. Whenever we talk about deserializing an object, we're talking about taking a blob of information, like some JSON or something like that, and we're going to somehow parse that JSON, take the properties out of it, and then put them on an object. So serialize is talking about saving something. Deserialize is talking about taking something that was saved and putting it back into our application. Okay, so now that we know those 2 terms, let's go back to this option. So with this option, we could try setting up class sync. Oh, let me remove that little typo right there. We could try setting up class sync to also define 2 interfaces, maybe an interface called serializable and an interface called deserializable. So the idea behind serialize is that some other class or some other object would have to implement the serialize method. Anytime serialize gets called, that other class, so in this case our user, would have to return some kind of object. Like we're not going to specifically say any here, we can at least say like, you have to return an object. So with this, we would say that the input to save would be first an ID, and the second argument would be some object that satisfies the serializable interface. So whenever we call save, class sync is going to take in that second argument right there. It's going to call the serialize argument on it, or excuse me, the serialize method on it, and it's going to expect to receive some object that's going to then send to that outside API. Now, the reason we're saying just like some object right here is to intentionally leave this vague. So if we just say some object right here, that means it could be an object with like, a name that's a string or an age that's a number. So by saying just some object, it leaves the option open to try to reuse class sync with other types of classes. And we're not suffering from that same problem we had back over here, where class sync was like totally locked into user props. Then anytime we wanted to fetch some information, we could require that we pass in something called deserialize, or some class that satisfies that interface. And so with this interface, we would require that other class to have a deserialize method that's going to take in some JSON data, and presumably it would then be up to that other class, in this case the user, to take in that JSON data, parse all that information somehow, and use it to restore all the properties on the relevant user. So this approach is, pretty good, but the downside is, once again, that we've got the output from serialize right here. At best, inside the interface, all we can really say is this is going to be an object with some properties. We can't specifically say what properties are going to be on there, because if we do, all of a sudden we're going to lock in this interface or class sync to be only good for class user. And the same thing is true of deserializable down here as well. So this is a good approach. It makes heavy use of interfaces, but it's still not great because, well, we lose out on some type safety here. We are not fully describing the types of information that are flowing around our app. Okay, so that's option 2, even though I called it option number 3. I reorganized these options at like the last second. So now we're going to take a look at the final option, option number 3. Okay, so this one is probably going to be the most complicated by a large margin, but it's also probably debatably the best way to go. So in this case, we're going to turn class sync into a generic class. Remember what a generic class is. We're essentially turning all the types inside this class definition, or at least some of them, into kind of like being a function argument. So this means that whenever we make use of class sync, we're going to specify the type of t. And then that type t is basically going to flow down and define all the different types inside of our class. So that means over here in class user, when we actually make use of sync, we're going to customize sync by specifying the type of t. So that means right here we would say, okay, wherever you see t inside of class sync, replace it with user props. And so that would allow us to describe very precisely the input arguments to save. Data of t would be essentially replaced with user props like so. So this way is debatably probably the best way, but like I said, it's also kind of the most complicated. One thing I want to clarify about this approach is that if we created a second class meant to represent some data, like let's say blog post, we absolutely could continue to reuse class sync over there, because when we define blog post sync property, we would say that sync was going to be a generic, and we would insert the type of like blog post props or something like that. And so we can customize class sync depending upon the needs of whatever class is making use of it. So again, I would say, yeah, this is probably the most appropriate solution, but we're definitely going to have to learn a lot more about generics along the way to really make this thing work. The other kind of interesting thing here is that it doesn't quite solve the scenario of fetching information terribly well. Well, I should say it does solve it, but it still puts some like demands back on whatever class is using class sync. So in this case, remember, the idea of fetch is that we're going to receive some information and then hopefully deliver it back to whatever class is making use of sync. So in this case, to get some information back from fetch over to our user, fetch would have to probably return a promise that's going to eventually resolve with user props, that object that we were just talking about. Now, I know that sounds really nasty, but we'll dive in really deep to that. I just want to mention it right now just to say, yeah, that would be kind of a requirement here that would have been a lot easier on this kind of interface with serializable and deserializable approach. Okay, so now that we've kind of taken a look at some of these options, like I said, we are going to go with option number 3 because it really is the most appropriate, but this is not without its own set of challenges. So let's take a quick pause right here, and we're going to start the implementation in the next video. All right, my friends, in this video, we're going to start to refactor class sync into a generic class. Now, usually creating a generic class is a little bit challenging, but this time we're going to use a little trick just to make it easier. So here's the idea. We're really doing two different refactors here. On the one hand, we're saying that we want to turn this thing into a generic class. On the other hand, we also are going to update our save and fetch methods to receive a lot of information about what we are saving and fetching coming from arguments. So in order to make this a little bit easier, we're going to first refactor our class, just assuming that we are using option number 1. So we're going to refactor class sync to have many different references to user props. That's going to allow us to avoid having to do anything related to generics up front. So we're going to get save and fetch working, assuming as though they were taking in arguments from some outside source. That'll be refactor part 1. And then once we complete that, we can then very easily go through class sync and essentially replace any reference to user props with a reference to the generic type that's coming in from the class definition. Well, let's give this a shot. As soon as we start writing code, I think you'll understand what I'm saying. Okay, so I'm going to flip back over to my editor and find my sync.ts file. At the very top, I'm going to immediately import that user props interface from our user.ts file. So I'm going to import user props from user. Right away, we will see an error message. That's because we are not currently exporting that interface from that file. So I'm going to flip on over to user.ts. I'll find my interface user props, and I'm just going to make sure that I export it like so. If I now go back over to sync.ts, the error is going to go away. Okay, so now we're going to rewrite sync, specifically fetch and save, assuming that we're going to have a ton of information coming from some object of type user props into both those functions. The first refactor we're going to do inside of here, and this refactor is kind of unrelated, but it's going to help out a lot with the later stuff we have to do. Remember how we said that we've got these really long URLs inside of here? Let's just fix that up right away. So I want to say that we're going to pass in the root URL that we're making these requests to as an argument to class sync when we create an instance of it. So I'm going to define the constructor function. And I'm going to say that this thing is going to be called with some public property that we're going to call root URL, and that's going to be a string. So now whenever we create an instance of sync, like say new sync right here, I want to require us to pass in some root URL like that. So now everywhere where we have that really long root URL, we can replace it with a reference to root URL. So I'm going to delete that little sample code up there. I'm going to get started on the axios.get statement right here. So I'm going to take everything from HTTP all the way to the end of /users. I'm going to delete that and replace it with $, curly braces, this.root URL. Now something really important here, notice how I still have a / in here. So the assumption is that when we create an instance of sync, we're going to pass in just everything from HTTP to users, and that's it right there. We're not going to put on an ending /. If we put in an ending /, then we would end up 2 in the URL that we're using for the request, which could definitely have a really bad impact. So again, when we create an instance of sync, that's what we're going to do. No last /. Okay, so that looks good. Let's fix up the other 2 URLs. So they're right here. So down here, I'm going to update that. I'm going to take everything from HTTP to /users and replace it with this.root URL. And same thing right here. In this case, we don't actually need any string templating. We can just replace the entire string with root URL like so. Okay, now I beg you, please check your spelling. Check all the characters in your URL right there and right there as well. If you have any errors on either of these, it's going to be really hard to debug later on. You're going to end up getting a 404 error, and you're going to think to yourself, why am I getting a 404 here? Okay, so now we fixed that. Let's start working on our save method. So remember, we want to pretend that we're going to receive all the data that we're trying to save as an argument into save. So I'm going to receive that as an argument that I'm going to call data, and it's going to be of type user props. So again, the idea here is that we are receiving all the data to save from outside source. And for right now, until we start to add in the generic code, we're just going to pretend that it is of type user props. So now we can take that data and throw it in as a second argument to our put statement. and the second argument to our post as well. All right, now just one more error inside of here. Notice how we've still got an error around this.get. So the assumption originally was that this method would have direct access to this.get on our user model, but that's no longer the case. Instead, we now want to try to get our ID out of this data property. Remember, user props potentially might have an ID property. It might, it's an optional property. So we want to look into that first argument. We want to see if it has an ID property. If it does, then we'll do the put. Otherwise, we will do the post. So I'm going to say that ID is going to come from data.id like so. Now I can use a little bit of ES2015 destructuring here and refactor that like so. Okay, so that looks pretty good. So I'm going to save this, and I'm going to go back up to my fetch method, and we're going to start to refactor this as well. So first off, the first error I see inside of here is something around this.getID. So chances are, whenever we call fetch, we are probably going to want to say that you have to pass in the ID of the record that you want to retrieve. So I'm going to say that whenever we call fetch, it must be called with an ID that has to be a number. So now I can fix up that statement right there. Rather than calling this.getID, I'm going to instead just reference that element or that argument that we just added in of ID like so. Okay, so now this is looking pretty good. And here comes the kind of hard part. Right now, after we make the request, whenever we get a response, we're going to execute this inner function right here. So we're going to take that response and update our model with that data. So this is now going to be a little bit more challenging because fetch, obviously, well, it doesn't have any access to this.set. That is a function that is implemented inside of user, not inside of sync. So we need to figure out some way of getting this response to be available to class user. To do so, I think that we should just change the signature of this method. And we should say that anytime we call fetch, we're going to return a promise that it will eventually resolve with the data that we get back from the API. So we're essentially going to say that now our user.ts file has to call fetch, it has to chain on a .then statement, and it's going to be up to class user to take this response right here and update all the user properties with it. So we're essentially changing the level of delegation here. We're saying now class sync is only going to be responsible for making the request, but as far as taking that data and doing something with it, well, that's now up to class sync. So I'm going to take that entire .then statement, I'm going to delete it, I'm going to make sure that I return that promise. As soon as I do so, I get an error because we had said that we were not going to return anything. And so we need to update our return type right here. So to express the fact that we are returning a promise from the Axios library, we're going to say that we're going to return an object of type Axios promise. That's what we are now returning. If you hover over that, well, we never actually imported that inside this file, so we need to import it at the top. So where I'm importing Axios, I'm going to add in another import of Axios promise, like so. And now that error goes away. Now you will notice that we are no longer making use of Axios response, so if we want to, we can definitely delete that import. Now, I know this Axios promise thing right here is probably just a little bit confusing. The only reason it's here is because when we call Axios, we get back a promise, and it is a promise that is implemented by the Axios library. So we're saying, hey, we're going to return an object that has all the properties of an Axios promise, and we provide a reference to where that type is defined. It is defined inside the Axios library. Okay, so that looks good. Now just one more very small issue. I'm now looking at fetch right here, and I'm saying, okay, every time we call fetch, we're going to return a promise that's going to eventually resolve with some data that is presumably customized to our user. So the last thing I'm kind of thinking about here is, well, what is the deal with save? When we call save right now, we have absolutely no indication whatsoever that the user has been successfully persisted to the backend. So when we call save, that's pretty much it. It's like a dead void. Nothing actually bubbles out of this method. We return nothing. No other part of our code base gets any indication that the user was saved successfully or that the save failed. So I think that we need to do something very similar to save as what we just did with fetch. I think that we need to return a promise so that whenever you and I call save, we will get back some object that we can use to determine whether or not the user was correctly persisted. So to do so, I'm going to update the return type of save, and I'm going to say that this is now going to also return an Axios promise. And then I'm going to make sure that in either of our if statement cases, we're going to return a promise like so. All right, and that's pretty much it. Okay, so that's class sync. So we've now written this thing out, assuming that we are always working with user props. So let's take a quick pause right here. When we come back to the next video, we're going to turn this into a generic class. And when we do so, we're going to see a couple of really interesting errors appear here. So we're not quite done with this thing. It's not quite as easy as replacing user props with a T. So let's take a quick pause right here, and we'll continue in the next video. In this video, we're going to start to refactor class sync and turn it into a generic class. So the overall goal here is to remove every reference to user props from this file. So to get started, I'm going to first find class sync, and I'm going to add on those angle brackets with a T inside them. Remember, we've said it many times, T is not some special identifier, it is just convention. So now we can go through this file, we can remove every reference to user props, and if we see any reference to user props inside the class, we will replace it with that capital T. So to get started, at the very top, I'm going to remove the import statement for user props. Then inside of the save method, we've got the argument type of user props right there, so we're going to replace that with a capital T like so. All right, so as soon as we do so, we're going to see a little error here. So we now have an error around ID. You might recall that before we started this application, we had a quick side discussion on generics. And when we spoke about generics in that side discussion, we said that sometimes we have a hard time referring to properties on a value that is a generic type. So the reason for that is that in this case, we are saying that data is going to be some generic type, some type that has not yet been provided. So we're trying to read a property off this type, or off a value with some unknown type. Remember, anytime we reference any property on any value whatsoever, Typescript wants to check to make sure that that property actually exists. So in this case, Typescript has no idea what type T is going to be, and therefore it doesn't have any idea if data is actually going to have an ID property. And that's why we are seeing this error on here. It says, hey, I don't know if this type T is going to have an ID property. So you might recall that we saw this on that previous discussion we had around generics. We saw it specifically around when we were trying to call a method on some class. Remember, we were talking about that like print method on either a car or a house. And we said that we could fix that up by making use of a generic constraint. A generic constraint is where we try to tell Typescript that whatever value or whatever type T that we pass in for our class, it will always have some given property. And we did that by defining an interface. So let's do that right here. We're going to define an interface, and we're going to use that interface to guarantee to Typescript that whatever type we use with class sync right here, it will have a defined ID property. So I'm going to say right here, interface has ID, and I'll say that ID is going to be a number. And then to make sure that Typescript understands that whatever type we use with class sync is going to satisfy this interface, we'll say T extends has ID like so. So now we have a constraint on here. We can now only use class sync with some type that will have an ID property that is a number. As soon as we add that in, you'll notice that the error message down there goes away, because now Typescript understands that whatever type data is, well, it's going to have a defined ID property, and it's going to be a number. So that looks like it solves the issue, but it turns out, well, there's kind of a side issue going on here. So let's take a quick pause. We're going to come back in the next video. We're going to try to use class sync, and we're going to see a little error come up that is related to this type constraint stuff. So a quick pause, and I'll see you in just a minute. In the last video, we defined class sync as a generic class. This class now has a constraint on it. So whenever we reference sync or use it as a type or do anything with sync whatsoever, we have to pass in a type right here that's going to have a defined ID property that is a number. So now that we've got class sync all put together, let's flip back over to our user.ts file and try making use of it inside there. As soon as we start making use of class sync inside of user.ts, we're going to run into another error. And this is going to be a really interesting error because it's kind of, in my opinion, a weakness of Typescript. We're going to introduce an error that we have to fix, and in fixing it, we're going to essentially introduce another bug into our program that TypeScript isn't going to find. So this is going to be an interesting little video here and the next one. So let's get to it. Okay, so we need to wire up sync back into our user, because remember, the entire idea right now is that we're trying to use a composition style approach. So at the top of the file, I'm going to import sync from the sync file. And now we need to somehow create an instance of sync and assign it to class user. Remember, we had a discussion about a couple of different ways to approach this. Right now, we had settled on assigning a hard-coded copy of, in this case, eventing to the events property of user. So whenever we create an instance of user, we're always going to get a copy of eventing. Remember, this is kind of a not super great approach right here, because it means that we cannot very easily swap out different submodules inside of class user, and that is one of the goals of composition. Now, when we did this with eventing, we said, well, that's probably okay because realistically, we're probably never going to swap out eventing, but the same is not really true of class sync. With class sync, we have an implementation of a syncing class that's always going to reach out to some defined API with a GET request to retrieve information or a put and post to save it. So in the case of class sync, it is very easy to imagine a scenario where we might want to sync data from a model to some outside source besides an API. So a very easy way, or a very easy case to think of, would be if we wanted to make some class that instead saved data about a user to local storage on a user's device. So in the case of eventing, well, probably not going to swap that out anytime soon, but in the case of sync, well, it's way more likely that we might decide to swap this out at some future point in time. Nonetheless, we're still going to define a kind of sync property on user, and we're going to hard code an instance of sync to it just to use the same technique as we did with eventing. Even though, like I said, way more likely that we might want to swap out sync at some point in time. Don't worry, we are going to come back later on and kind of address this shortcoming. Okay, so I'm going to say, inside of class user, whenever we create an instance of a user, we're going to get a public property that we're going to call sync. It's going to be an instance of the sync class. As soon as we put down sync, we get an error right here because we have to specify a generic type for it. So we want to create an instance of sync where we're going to use user props. So remember, that means that inside of class sync, wherever you see T, we're going to replace it with user props, just like we had before. So I'm going to put inside of here user props. Then this is going to be an instance of sync that is configured to use user props. And remember, anytime we create an instance of sync, we have to pass in a URL to use as the root URL. So this would be way better. Remember, we had set this up as a constructor property because we wanted to make sure we could customize the root URL to save some data to when we actually created an instance of sync. So we just have to pass in essentially our local host path right there. So I'm going to define this as a separate variable above the class. I'll say root URL is http://localhost 3000/users like so. Then we can pass that into sync. Perfect. All right, so I'm going to zoom out here, and now here is the interesting error that we have to deal with. So this is the error that we're going to fix up, and in the process, we're going to kind of introduce another error into our application that TypeScript is not really going to detect. So let's take a quick pause because we're going to need just a little bit of time to understand exactly what's going on here. So quick pause, and I'll see you in just a minute. In the last video, we added in a generic constraint to class sync. And now when we specify sync right here for our sync property, and then eventually create an instance of it, we pass in user props for that generic constraint. But now we're seeing an error message around it. And the error message says, same thing in both cases, essentially something about how user props does not satisfy the constraint has ID. And then if you read really closely, it says property ID is optional in type user props, but required in type has ID. And that's pretty much the whole issue here. Right now, we are passing in interface user props for our type constraint. But inside of user props, ID is marked as being optional. Over inside of sync_ts, has ID says that whatever type comes in for T has to have a required ID property that is a number. And that's the source of the error that we are now seeing. Either we have optional over here and required over here. So in one case, TypeScript is saying, hey, you know what? If you're not going to have this property, I don't want to deal with you. So that's pretty much it. So in order to fix this, all we really have to do is mark the ID property inside of our interface as optional as well. Okay, so that's pretty much the fix. And then as soon as we make that change, the error goes away back over here. But this idea around optional properties kind of brings up a more interesting topic. You might recall that down inside of our save function right here, we had a reference to data.id. And we made this whole big idea around IDs sometimes being defined and sometimes not being defined. And depending upon whether or not ID was defined, we wanted to have some very significantly different behavior. So now, the thing that's kind of awkward here, if you mouse over ID, you might notice that it has a type annotation of being number. So what you're seeing right here is the default behavior for optional properties in TypeScript. And we've been using the default behavior of TypeScript throughout this entire application. But in some other locations or other projects we've worked on inside this course, we've had TypeScript kind of inadvertently set up in a slightly different mode. So let me show you what I'm talking about. I'm going to flip back over to my terminal, and inside of my project directory, I'm going to generate a tsconfig file using tsc --init, like so. Remember what that does? That creates a tsconfig file. And inside that file is a lot of different configuration for the TypeScript compiler. So I'm going to flip back over and very quickly open up that file without worrying about anything else that just occurred. So all we just did was generate this file, nothing else whatsoever. Now I'm going to scroll down this file a little bit, and I want to point out one very important section inside of here. And that section is strict type checking options. And one setting inside of here says strict true. Now, if you read the description or comment for that setting right here, it says enable all strict type checking options. So by just having this tsconfig file existing, like the default tsconfig file inside of our project, we are changing the behavior of the TypeScript compiler. By default, strict right here normally is false, like so. So by just generating this file, we have changed how the TypeScript compiler behaves. And now all of a sudden, we are doing a bunch of additional checks on our code base. One very important check that was just enabled by having this file inside of here is a rule called strict null checks. So what strict null checks does is it takes a lot of scenarios where TypeScript kind of gives us the benefit of the doubt, and it instead requires a lot more rigor in how we treat different values and different properties inside of our app. So to give you a really good idea of what that rule right there truly impacts, I'm going to flip back over to my sync.ts file. And now I'm going to once again mouse over my ID property. And remember, at this point in time, the only thing we have changed is to generate that file that has that one setting enabled. And so when I now mouse over that property, you'll notice that the type of ID is now very, very different. Now it is either number or undefined. And this is a way more better way, in my opinion, of reflecting optional properties. So again, TypeScript's default behavior, even if we mark a property as being undefined or optional, it kind of gives us the benefit of the doubt. It says, okay, this is an optional property, but we're just going to assume that it's always going to be defined. And that's what you saw just a moment ago when we moused over ID and we had an annotation of number. So by just turning on that one setting, which we did by just generating the tsconfig file, we have now gone into this very different mode, where now optional properties are going to be either a number or undefined. And so now the if statement that we have right here makes a lot more sense. The if statement, where we check to see if ID exists, is essentially functioning as a type guard. TypeScript understands what we are doing with this if statement. We are checking to see if that variable is defined. And so inside of the if statement, if we write out ID and now mouse over it, it will have a type of only number, because TypeScript understands that in this scenario, there's no way we could enter this branch of the if statement if ID is undefined. Likewise, if I write out ID down here in the else case, TypeScript's going to say, well, okay, maybe not quite so smart in the else case this time around. I guess it only works correctly on the if statement, but now you can see that we kind of lost that type guard. Okay, so the big takeaway here, what I really wanted to convey is that when we use optional properties, we're going to see that our code behaves very differently depending upon that one single setting inside of our tsconfig file. So by not having this file inside of our project before, well, it made the TypeScript compiler treat our code very differently. And by just generating it, now all of a sudden, we're going to have some very different experiences around types inside of our app. Okay, so now I am going to save this file. And believe it or not, I'm actually going to delete the tsconfig file. So right now, with the version of the application we're putting together, I really don't want to have strict mode turned on just yet, because it's going to show us a lot of other errors that are pretty unimportant as far as the application stands as it is right now. So I'm going to now delete the tsconfig file. As soon as I delete it, I can now wait a second or two, and if I now mouse over ID again, you'll see that we've now fallen back to the default behavior, where ID is now considered to be a number and nothing else. All right, so now just so you know, later on inside this application, like this app we are currently building, we are going to regenerate that tsconfig file and handle all these different kind of errors that are going to pop up in our code once we enable that strict mode. But for right now, like I said, we're just not going to worry about that strict setting just yet. All right, so quick pause right here, and we'll continue in the next video. All right, my friends, in this video, we're going to start up our last extraction of logic out of class user. So we're going to create a new attributes property on class user, and that's going to point at some object of type attributes. So the goal of this attributes object is going to be to store information related to a user, like name, age, and so on. This extraction is probably going to be the easiest, because essentially all we are talking about doing here is copy pasting or cut and pasting the remaining constructor and get and set methods out of class user. So these three methods right here, constructor, get, and set, are all about handling user information. We're now saying that we want to extract all that into this separate submodule, or kind of composition style class. So let's get started. I'm going to first get started by opening up my models directory and creating a new file called attributes.ts. Then inside of here, I'm going to create and export a class called attributes. Then I'll go back over to my user.ts file, and I'm going to cut and paste the constructor, get, and set. So I'll cut. Then I'll go over to attributes.ts, and I'll paste like so. All right, so I'm going to zoom in just a little bit, and we're going to start making a couple changes to this thing. So first off, we have a reference to user props inside of here. We're going to go through the same refactoring that we just did with sync. We need to turn attributes into a generic class so that this thing will not have any reference to user props. Remember, if attributes has a reference to user props, then it's only going to be good for working with our user model. And eventually, we want to have some kind of very, reusable model that we can use to represent different types of data, such as a blog post, image, comments, and so on. So we don't want attributes to be very custom tailored to only working with user props. So to fix that, I'm going to add in a generic type right after attributes, and then we can go through the class definition and update every reference that we see of user props. So I'm going to change the constructor signature to say this is going to take some object that's going to satisfy the T type, and then the same thing for update as well. All right, so there's one other little issue inside of here. You'll notice on the get method, we didn't really specifically refer to user props, but we are saying that from the get method, we are only ever going to return either a number or a string. And chances are that's only going to be good for our user props interface. We might have other types of data inside of our application that might have Boolean values on them, or maybe some kind of nested object or something like that. So saying that get is only ever going to return either a number or a string is really not appropriate anymore, even though we don't really have an error message here or anything like that. So let's take a quick pause. I'm going to save this file and user.ts. We're going to come back in the next video. We're going to learn how we can update this type signature right here to something that makes a little bit more sense, given that we don't really know what type of value we're going to return. So quick pause, and I'll see you in just a minute. In the last video, we spoke about how the return type signature of our get method is not quite appropriate. So right now, it's either a number or a string that we are returning. For just a second, I want to imagine that maybe we put in a limitation inside of our application. We say that we can only ever have attributes that are maybe like a number or a string or a Boolean. So we basically have the basic types covered here. So maybe we just run with this and we say, okay, we can only ever store these types of values, and then boom, all of our code would work just fine. Well, for the most part, just fine. If we went down this route right here, and I do not recommend it at all, I want to show you a little bit of code that we would have to write anytime that we want to access a property through this get method. Once you see this kind of difficulty, you'll then have a better understanding of why we want to get away from this union pattern that we currently have. So I'm going to write out a little bit of sample code. I encourage you not to write out the sample code just yet, because I'm going to delete it very quickly. All right, so I'm going to try creating an instance of attributes with user props serving as our type. And then we'll take a look at how awkward it would be to make use of the current get method. So at the top, I'm going to import user props. And then down at the bottom of the file, I'm going to create an instance of attributes. So I'm going to create a variable called adders, short for attributes. I'm going to say this is going to be a new instance of attributes. I'm going to give the generic a type here. So I'm going to say find all instances of t inside this class and replace t with user props like so. And then I'm going to also pass in a starting set of properties, or as we call it, data. So the initial data for user props here or attributes is going to be an ID of 5, about a name of whatever, and an age of 20, like so. Now I'm going to new line this just so you can see this a little bit more easily. There we go. That's better. Okay, so now let's try to access, say, ID through adders, or specifically through the get method. So to get access to ID, we would do something like const ID is adders.get, and then we would pass in the string of the property that we want to retrieve. So now here's the issue. If we now mouse over ID, we get back a type annotation on ID of string or number or Boolean. Remember, that's what our type annotation for the return value right here says. Anytime we call get, we're going to return one of these possible types. So before we can access any properties on ID that only belong to a number, we have to set up one of those type guards. Remember, we spoke about type guards a little bit ago. If we try to access any properties on ID right now, we will only see the properties that are common between number, string, and Boolean. So to treat ID truly as though it were a number, we'd have to set up a type guard by writing out something like if type of ID is number. Then inside of here, we could treat ID as though it were a number. If I mouse over ID, you'll see that I get the annotation. Yep, it's a number. And so now I can access all the properties on there that are common to numbers. So we would have to repeat this same kind of type guard every single time we try to access a property off of our attributes object. And clearly, this is not really a pattern we want to go down. It would be much better if we could somehow just call adders.get and then have whatever value we get back be of the correct type. That would be super ideal. So ideally, I would love to be able to just say, okay, this ID right here, if I call get with ID, ID will be a number 100% of the time without any extra hassle or anything like that on my side. Now, one way we could do this would be to put on a direct type annotation, like so. But if we try to do that, we're going to very quickly see a message that says, hey, you have one of these possible values, and you cannot just assume that it is of type number. So that would not quite work out. The other thing we could possibly try doing is using a type assertion. Remember, a type assertion is where we try to override Typescript's behavior and just say, look, Typescript, we know what we are doing. Just believe us. Believe us when we say that ID is a number. So we could add on a type assertion by writing out adders.get and then as number like so. So that right there is the type assertion. We are trying to just override Typescript and tell it, look, whatever we get back from this function call, it's going to be a number. Just trust us. And so if we now mouse over ID, yep, it's a number. But obviously this approach has a downside. If we ever come back through our code and decide, hey, you know what, instead of ID, we actually want to get our name. So we put in name right here, name right here. Well, name is definitely not a number. So chances are, if we write out some code like this, Typescript would think that everything is okay. But when we try to run it, chances are something would not be working as expected, because we are now treating name, which is definitely a string, as though it were a number. So it's clear that all these different possible solutions have, well, some really big downsides. So we need to figure out a way to just be able to call adders get name and have Typescript really understand what we are trying to do. With just this code right here, we need Typescript to understand that name is 100% of the time going to be a string. So that's the big goal here. That's what we are trying to do. Now, to make that happen, we're going to have to use some really complicated syntax around generics. So rather than just writing out the syntax, I just want to build up kind of an understanding for what you and I are going to try to do. So we're going to take a quick pause right here. When we come back in the next section, I want to point out two really important things about JavaScript and TypeScript And once we have those two important facts as a base, we'll then be able to start writing out some kind of advanced syntax around the get method right here and have this line of code just work correctly. Okay, now before we take a pause, I'm going to delete all the sample code I put on here because I told you not to write it. And I'm back to how it probably looks for you. So I'm going to save this file, I'm going to take a quick pause, and I'll see you in the next video. In the last video, we established that we need to do some major work on our get method. So I told you that we're going to fix this and make it really nice using generics. But before we do that, we need to build up some understanding around two really important topics. So let's get to it. Okay, so here's the two really important things for you to understand. First off, in TypeScript, strings can be types. Now, this sounds a little bit crazy, so basically we're just going to write out a little bit of code to explore this idea. So I'm going to flip back over to my code editor, and down at the very bottom of the attributes.ts file, I'm going to write out just a little bit of sample code. Again, we're going to delete this very quickly. So you might recall that back when we created a tuple much earlier, we used some syntax. We referred to it as a type alias. So when we created a tuple, we wrote out something like type, match data. That's what it was. Then we wrote out an array and all the types that we expected to be in there at their precise indices. So we had like string, number, whatever it was. So we can use this type alias syntax to also create new types using other values, besides just an array like the one you see right here, or technically a tuple. So we can use this type alias syntax to create a type out of a string as well. To do so, we could write out something like type, then the name of the type, maybe I'll put down like best name, and then the type is going to be a string. In this case, the best name is going to be, well, of course, Steven. I'm just kidding, but just as an example. So even though it looks like we are doing a variable declaration here, we are actually creating a type. So I can use the word best name in any location where I would normally put a type annotation. For example, with a function call. So I'm going to define a function here called printName. We're going to call printName with some string, but more than just being any string, I'm going to say that the only possible type of value that you can pass into this function is a type of best name. So I'm going to call that argument name, and then I'll annotate it with the type of best name. And then it's not going to return anything. So if we normally built out a function like this and put in a type annotation of string, that means we could pass in any string here that we want whatsoever. But by putting in best name, with best name being a type, we are essentially saying you can only call printName with a string of Steven. If I try to call printName with any other kind of string, I'm going to get an error. So if I call it with any gibberish like so, nope, not allowed, because this string right here is not of type Steven. That's essentially what we're saying. So the only value that I can call printName with is a value of type best name. And for a value to be of type best name, it must be a string, and it must have the characters Steven. So I can call printName with Steven like so. Notice how that call succeeds, all the others fail. Now this might seem like a really crazy thing to have inside of TypeScript, but it turns out there's a lot of scenarios where we kind of do want to create a type out of a string. The actual use case we're going to use it for in just a moment, well, obviously it's going to kind of solve a problem like this, but there are many other applications where we would want to create a type out of a string. And if you're at all familiar with, say, Redux, well, it turns out that being able to type your actions, which remember have a type property that is usually a string, turns out that this kind of feature is really nice with Redux. I just want to throw it out there really quickly. Okay, so now that we understand this idea that in TypeScript a string can be a type, I'm going to delete the sample code, and we're going to go look at the second big thing to understand. So here's the second big thing. In JavaScript, and therefore TypeScript as well, all object keys in reality are strings, even if you actually think it is a number. So for this point right here, I'm going to open up my browser console. I'm going to write out a quick code snippet. All right, here we go. So I'm going to create an object called, I don't know, let's do colors. That's my favorite one. So I'm going to create an object called colors. I'm going to make it an empty object. I'm going to say I want to add a property to this thing. And I want the property to be like, how about red, whatever. I'm going to assign that a value of red. Okay, nothing too crazy yet. If I print out colors, I get red, red. Let's now try doing the same thing with a number, or using a number as the key. If I want to use a number as a key in a JavaScript object, I have to use that bracket syntax. So I can say like colors at 5 equals the string red like so. So now it would appear that I'm using a number as a key. If I hit that and then print out colors again, I can even see the key right there. And it really looks to me visually from this debugger as though the number 5 is a key. And heck, I can actually even verify that. I can put in colors at 5, and if I do so, I'll get back red. So once again, I've got some kind of thought process here, or I got some evidence that makes me think that the key is possible to be a number. But in reality, that is not what is really going on behind the scenes. You see, whenever you use a number as a key like this, behind the scenes, JavaScript takes that number and it first turns it into a string. And that happens anytime you try to access a property or set a property on an object. So in reality, even though we really think that we are using a number here as a key, no, it is a string. And to prove it, we can write out colors and then 5 as a string. And if I run that, I still get back red. So even though you really think you're using a number here as a key, no, internally it is first being converted into a string, and then that string is being added to the object as a property. All right, now that might seem like it's really irrelevant, but I want you to think about the impact of these two rules together. So in TypeScript, a string can be a type. And then we are secondly saying that in JavaScript, and therefore TypeScript as well, all object keys are strings. So if we kind of put these two facts together, what does it tell us? Well, it tells us that on an object, or the keys of an object, can actually be a type as well. Now, that might sound really strange, but I just want to throw this sentence out once again, because it's kind of hard to picture in your head. In TypeScript, the keys of an object can be a type as well. Now, just saying that, like so many things inside this course, just saying that doesn't really give us any further understanding. So let's take a quick pause right here. When we come back in the next section, we now have enough knowledge to put together this kind of crazy generic syntax on our get method. So we're now going to start to add in the crazy generic syntax, and then we can go over the syntax and really understand what is going on. So quick pause, and I'll see you in just a minute.